Right. Chapter number 3. Chapter number 3. Chapter number 3. What is the question number 1? Chapter number 3, question number 1. You know very well. C is the answer. Next one. See, chapter number 3, question number 2. What is the answer? Binary trees, unlabeled binary trees. I think what is the answer? B. B is the answer. Chapter number 3, question number 3. Right? Let's see this one. A program takes as input a balanced binary search tree with n leaf nodes. It will take input a balanced binary search tree with n leaf nodes. Roughly like this. A balanced binary search tree with n leaf nodes. Can you help? How many leaf nodes? N. Right? These are n. For the question number 3, input is going to be a balanced binary search tree with n leaf nodes. Yes, n leaf nodes. And one more. It is a, please be careful, it is a balanced binary search tree. N leaf nodes are there. Because of 2 people becomes 1. Here how many? N by 2 leaf nodes. N by 2 nodes are there. Here n leaf nodes, definitely 2 people becomes 1. Here n by 2. Here if you see, again 2 people becomes 1. N by 2 square. It will continue. See this one. First one is going to be n by 2 power 0. Next one is n by 2 power 1. Next n by 2 square. If you continue like this, one, what is the answer? Top level if you observe. Always by 2 by 2. N by 2 power log n approximately. Everyone, 2 power log n is how much? N. N cancel, 1 will be there. So n leaf nodes. N by 2 power 0 is n only. Because of 2 people becomes 1, n by 2. Again 2 people becomes 1, n by 2 square and so on. Lastly, if you divide always by 2 by 2 by 2, log n time, n by 2 power log n. That's okay. Next, what is saying? A program takes as input a balanced binary search tree with n leaf nodes and compute the value of function g of x for each node. For every node you will apply g of x function. Every node, not one place, 2 place, every node you will apply g of x function. Some people are asking, because of everywhere he is applying g of x function, what is the g of x function cost? Right, see the g of x function cost. If the cost of computing g of x is minimum of number of leaf nodes in the left subtree, comma number of leaf nodes on the right subtree. Can you help me now? What is the g of x function cost here? Right, here g of x function cost is going to be number of leaf nodes in the left subtree, how many? 0. Number of leaf nodes on the right subtree, how many? 0. 0 comma 0, what is the minimum? 0. So here g of x function cost is 0. Here also number of leaves left and right, both the side 0. So everywhere you will apply g of x function cost. Everywhere you apply g of x function cost is going to be minimum of number of leaf nodes on the left and right. So because of these are leaf nodes, no cost, nothing, because no left is there, no right is there. So how many nodes at this level? N by 2 power 0 nodes. What is the cost at everywhere? Because everywhere you will apply g of x function whose cost is 0. Similarly, can you help me now? Here also g of x, what is the cost? Minimum of number of leaf nodes on the left and right. Left 1, right 1, minimum is 1. Here also 1. That is advantage with the balanced tree. So n by 2 nodes are there everywhere, 1 cost. Again here g of x, what is the answer? Minimum of number of leaf nodes in the left and right. Left number of leaf nodes 2. Right number of leaf nodes 2. Minimum is 2. Right? Same thing will happen everywhere. It is also 2. Finally, n by 2 square nodes into 2. If you go, what is the answer? Previously left and right becomes, when you go above, left and right becomes one side only. So I think it will become 4. Please check. So what is the answer? Next one if you go n by 2 cube into 2 square. Right? Previously left and right becomes, when you go to next level, they both will go to one side. That is the reason double K. It will continue like this one. If you observe clearly, 2 power 1, it is a 1. 1 means what? 2 power 0 maybe. 2 square, it is a 2 power 1. 2 cube, it is a 2 square. If you go here, n by 2 power 4 into 2 cube, check. This is going to be n by 2 power log n into 2 power log n minus 1. 1 less. Right? 1 less. Can you help me now? N by 2 power log n into 2 power log n minus 1. Both will be cancelled. What is the answer? N by 2. This is n by 16 into 8. N by 16 into 8. What is the answer? It is also n by 2. It is also n by 2. Check yourself. It is also n by 2. It is also n by 2. How many times? Log n time. Log n times n by 2. Finally n log n. So to this problem, question number 3, what is the answer? B. Question number 3, answer is B. This is the way. If anyone having small doubt also, please check. Balanced binary tree with n leaf nodes. Yes, here n means next level n by 2. Next level n by 4 and so on. Everywhere g of x function cost. Find out what the g of x is doing. G of x is doing number of leaf nodes on the left and right, whichever is minimum, that is the cost of g of x. So question number 3, answer is going to be second option. Question number 4, it is the manual checking only, check nothing there. Question number 4, what is the answer? C, manual checking only. Next one, question number 5, it is there in your notes also, I done already. What is the answer? Question number 5, using heap sort. Question number 5, we done already, A. Next one, question number 6. Question number 6, what is the answer? It is the D, it is there in your notes. Next one, question number 7, it is the manual checking only, try this one. Question number 7, what is the answer? Manual checking. So what is the question number 7 saying? The number of leaf nodes in a rooted tree of n nodes, where each node contains 0 or 3 children, right? Let me check it, 0 or 3 children. Rooted tree of n nodes where each node is having 0 or 3 children. The number of leaf nodes in a rooted tree of n nodes, total nodes are n. The number of leaf nodes in a rooted tree of n nodes, totally n nodes are there, with each node having 0 or 3 children. He is asking leaf nodes how many? Leaf nodes how many? Right? Let me ask one small, rooted tree of n nodes. Rooted tree of n nodes. Can you see how many nodes here? Count. N nodes. How many are there? Just count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Totally, I think n value 10. Substitute now 10. Can you help me now? 10. What is the option A? 10 by 2, 5. 5 leaf. Check. 1, 2, 3, 4, 5, 6. No. Can you say what is the option B? Right? 10 minus 1, 9. 9 by 3, 3. 3 leaves only. No. What is the option C? Right? What is the answer? 10 minus 1, 9. 9 by 2, 4 point something. No. What is the option D? 2 into 10, 20. 20 plus 1, 21. 21 by 3. What is the answer? 7. Let's check. 1, 2, 3, 4, 5, 6, 7. Manual checking, nothing there. So question number 7. What is the answer? D. Manual checking. Well, I am not done anything. There are so many questions in the previous papers or next year gate exam also. Right? Manual checking only, you can do most of the things. Next one. Go to the question number 8. So question number 8. Question number 8. This one will come in the data structure tree chapter. Data structure tree chapter it will come. Right? We will do anyhow this one. So the answer of this problem is going to be, the answer of this problem is actually, right, big O of n. This is the answer. Right? Now substitute. So big O of n means, what is the answer? N, A value should be 1. But he is saying that the actual answer is, this will come in the data structure trees chapter. It will come. Actual answer is order of n. But he is saying what is the answer? He is saying order of n power a log n power b. That is the thing what he is saying. Right? Now check. I want answer as n. But he is saying this is the answer. So a should be 1. B should be 0. A should be 1. B should be 0. So log n whole power 0 becomes 1. So n power 1 is n. N is the answer. So finally, what is the value of a plus 10b? What is the answer? A is 1. Right? So a is 1. 10b. What is the b? B is going to be 0. So 0. Finally 1. Check properly. A plus 10b. A is 1. B is 0. Finally answer is 1. Question number 8. Answer is n. Next one. Question number 9. Question number 9. What is the answer? Question number 9. Adjacency list is preferred over adjacency matrix when the graph contain very less edges. Less means what? Sparse. So I think D. Question number 9, D. Sparse graph. More edges are there, dense graph, adjacency matrix. Less edges, sparse graph, adjacency list. Question number 9, D. What is the question number 10? Question number 10, please check yourself. A. These are very small thing. Just taking one example and verifying yourself. Question number 11, answer is C. Question number 11, answer is C. This is right to this problem. For the question number 11, answer is C, that is 5. To this problem, right, formula is there, right, which is the, I think, question number 4 and question number 11 both are same. Question number 4 contain formula, question number 11 contains substituting values. Finally, question number 11, answer is going to be C5, right. To this problem, formula is given in question number 4, right. Please you take care. Question number 12. Question number 12. Let me read the question number. Suppose we have a balanced binary search tree holding n numbers. We are given two numbers L and H. Wish to sum up all the numbers in T that lie between L and H. Suppose there are m such that numbers in T. If the tightest upper bound on the time compute the sum is n power a log p, n power a log power ba, right, m power c log power d, the value of a plus 10b plus 100c plus 1000d is, right. This is the question given, right. It is given in 2014, it is given in 2020 also. Question number 12 is given 2014 also, 2020 also given, right. So what is the answer for this one? I will explain once. See this one, this is the answer. Question number 12, this is the answer. Please see, it is the BST. BST means what? Left smaller, right greater. And one more, it is the BST or balanced binary search tree, right? I think it is the balanced binary search tree. BST means binary search tree, balanced BST. Another name is AVL tree. Question number 12 belongs to AVL tree. Question number 12 belongs to AVL tree. Please be careful. It will come in the data structures. Nothing there. BST and AVL tree both are same. In the BST binary search tree, balancing may be there, may not be there. But in the AVL tree, balancing is there. What is the meaning of balancing? Log n levels. Right? In the AVL tree, log n level tree only will be there. There is a balanced BST. Now let me give some values also. What is the meaning of BST? Left smaller, right greater. Let me check here. It is the 50, it is the 40, it is the 30, it is the 20, it is the 35. This is going to be here. Let us assume that here 45, it is the 43, it is the 48. BST means left smaller, right greater, nothing there. Next one, it is going to be, let me try this one. It is going to be, right, 80. It is going to be 90, it is going to be 100, it is going to be 85, it is going to be, I think, 70, it is 75, it is going to be 60. There is a BST and one more thing, it is the balanced BST AVL tree. AVL tree contain log n levels. Please be careful. Whenever is not mentioned balanced one, there may be a chance of n levels also. I am repeating once again. Question number 12 is talking about AVL tree. Question number 12 is talking about AVL tree. AVL tree is nothing but balanced BST. BST means binary search tree. Left smaller, right greater. Right. Question number 12 is talking about AVL tree. AVL tree means balanced BST. BST means binary search tree. Binary search means left small values, right greater values. But when you say BST, left small values, right greater values, it's okay. But BST may be balanced, may not be balanced. But when you say balanced BST, it is always balanced. In the balanced BST, log n levels only there. In the BST, n levels may be there, but in the balanced BST, log n levels. In the balanced BST, minimum levels also log n, maximum levels also log n. But in the case of the BST, minimum levels are log n, maximum is n levels. Only BST given, minimum levels log n, maximum levels are n. Balanced BST, everywhere log n. So in this problem, he is talking about balanced BST. So what is the guarantee? Always log n levels. And one more, because of it the BST, left small elements, right greater elements is 150. Right? Left side if you see all small, right side if you see all greater. Same thing here also, 90. Left all smaller, right all greater. Next one 80. Left all smaller, right all will be greater. So comparing this 80, left small people, right greater people. Everywhere happened. So now let me see once again now. Question number 12, it is talking about balanced BST, which is also called AVL tree. AVL tree with n nodes, right? Log n levels will be there. And one more, because of it the BST, left smaller, right greater, right? Please be careful. Now afterwards, after getting all these entire story, whatever I discussed, now if you want you can check. See this one. In this tree, what are you checking? See this one. We are given two numbers, L and H. Right? In this problem, he will give two numbers to you, L also, H also. Right? In this particular tree, he will give two numbers. In this problem, right, from this tree, he will give two numbers, L also and H also. According to this problem, we are given two numbers, L and H. Right? From this tree, right, he will give two things, L and H. Now his goal is, assume that L and H given, assume that L is this and H is this one, assume that somewhere H is this one. From this tree, in this problem, two numbers are given, L and H. Assume that L is 35, H is 75, assume. Right? Now what is his goal? We are given two numbers, L and H, and wish to sum up all the numbers in T that lie between L and H. His goal is given L also, is given H also. His goal is from L to H. Right? In this particular BST, L to H, what is the L? 35. What is the H? 75. Right? From 35 to 75 in this particular BST, whatever elements are lie between 35 to 75, including them, you have to add all of them. Can you help me now? Right? From 35 to 75, including them, who are those? 35. In between numbers only, 35 to 75, all the numbers. Who are those? 35. Ascending order. 35, what is the answer? 40, 43, 45, 48, 50. Next. 60, 70, 75. See this one. 35 to L is 35. H is going to be 75. L to H. I think these are the numbers. You want to add all these numbers. Now can you help me in this problem? What is given? One balanced BST given. What is the one more thing given? L and H also given. What is the L? 35 assume. What is the H? 75. What is his goal? L to H including them. Whatever elements are there, you have to add all of them. Now next one. And one more, see the interesting thing. One more thing. We are given two numbers L and H and wish to sum up all the numbers in T that lie between L and H. Suppose there are M such that numbers. Suppose there are M such numbers in T. Suppose that these all are M people. These all are M people. Isn't that? These are M. He himself mentioned. Tree contain N elements. It's okay. But right, L to H, the number of elements present is M numbers. Totally, isn't that M numbers? Total sum is not M. Number of elements are M. L to H, number of elements present is M numbers. This tree contains N elements. Please be careful. Can you help me in this problem? What is given? One balanced BST given. What is the one more thing given? L and H also given. Next one. L and H. L to H, how many elements are there? M numbers, he said. Total elements, how many? N. Right? What is his goal? L to H, whatever elements are there, you have to add all of them. Now one more thing. This one, if the tightest upper bound on the time compute is given time complexity also. To solve this problem, what is the solving this problem? L to H, whatever elements are there, you have to add all of them. Where number of elements are M such numbers. To add all these things, right? How much time he is asking, right? I think if you want to find out time complexity to get from L to H how many, what is the first thing you have to do is, right? In this balanced BST, first to find L. He is given L, first to find, because you have a tree and he is given L and H in the tree where they are, how you know? So that is the reason using, listen, because of the balanced BST, right? In this particular ABL tree, right? Using the ABL tree, greatness is H property, right? In this ABL tree, first to find L. Next one, in this ABL tree, right? Next to find H also. After finding L and H, can you help me one small line now? In the ABL tree, to find someone, how much time? Worst case, best case. When I ask this person, are you L? Yes, stop. Best case 1. Worst case, right? Are you L? No. But I want L. What he will say? Go left, because you want less than me. Again, are you L? No. I will ask him, where should I go? He is saying that you want less than me. Go left. Are you L? No. Where I have to go? You want more than me. Go right, like that. So everyone know BST means search tree, right? In this ABL tree, if you want to add from L to H, first to find L, right? To find out this L in the ABL tree, worst case time is going to be log n, because the log n levels are there, right? First find L. This is the algorithm. See, first step, find L. In ABL tree, first to find L. Find L will take how much time? Maximum log n time. Maximum log n time. That is the first step. Second step is going to be this one. Second step. After finding L is over, second step is going to be from there. Listen, from there. Find L, it's okay. From there, from L, apply in order. First is going to be find L, log n. Second step is going to be from L, apply in order. From L, try to remember, right? If you apply in order from any node, what will happen? From that place, all ascending order will come. In the tree, from that place, all ascending order will come. Can you help me now? From L, apply in order. In the BST, careful listen, in the BST, if you apply in order, ascending order will come. Already did the BST, in the BST from L, right? In the BST from L, apply in order, right? You will get ascending order. So what is the meaning? From here, ascending order will get like this. And one more thing, listen, one more interesting answer. From this place, if you apply in order, it is the BST. From this place, if you apply in order, what will happen, right? So from this, right, what will happen, right? So from in the total tree, in order will come, ascending order. From this root node, if you apply in order, it is the BST. So what happened? Total tree in order will come. Right? So please be careful. From this node, if you apply in order, what happened? Before that, it don't give. From there onwards. Again, I'm asking you. See this one? See correctly? First step is going to be find L in this ABL tree. How much time? Worst case log n. Next one, from L, apply in order. Try to remember, in the BST, if you apply in order, right, from L, what happened? From L, whatever elements are there in this particular BST, right, ascending order will come, means all these will come. Now next one, one more thing. N nodes, careful listen, N nodes in order will take N time. N nodes pre-order will take N time. N nodes post-order will take N time. In the similar way. From L, you are applying in order. From L, you are applying in order. In order will give ascending order. Because of BST in order is ascending order. From where? From L you are applying in order. So from L means from 35 you will get the ascending order. Because of in order, BST, ascending order will come. So from L means from 35 apply in order. So from 35 onwards you will get the ascending order. Some people are asking continue until what is the answer? Until H will come. And one more thing, total tree, N elements are there. In order will take N time. L to H, how many elements are there? L to H, M elements are there. In order will take M time. From L onwards, you are applying in order until H will come. What the in order will go? BST, ascending order. From where? From L to until H will come, apply in order. L to H, how many elements are there? M element. N elements BST, this one. N elements in order will go N time. N elements, right? M elements in order will take M time. Can you help me now? This is for finding L. This is for from L to apply the in order, right? M time. Some people are asking why M time? From L you are applying in order until M elements will come. So M time. So total time is going to be, what is the answer? Log n plus M. Total time is going to be log n plus M, right? Log n plus M. Please be careful. Can you help me? Log n plus M, it's okay. What is the upper bound? Log n and M, which is the upper one? Right? Which is the upper bound? Supposition that, right? I think clearly we don't know, right? So I think let's see the problem. Time complexity of this algorithm is mentioned already. This one. The time complexity of this algorithm is going to be log n plus M. Who is bigger? Who is bigger? If at all M close to n, then it is bigger. Right? Suppose that M is very small number, then this is bigger. We don't know. When you don't know, keep both. Big O of both. To this problem, what is the first step? Find L. Second step, from L, apply in order. When you apply in order in the BST, ascending order will come. When you apply in order, right, from L onwards, all elements will come in the ascending order until H will come. So L to H, how many elements are there? M. N elements in order will take N time, right? M elements in order will take M time. So total time complexity log N plus M. Log N plus M, right? Please be careful. I'm thinking that you are a little bit okay, but what is the time complexity? E given. E given already. How much? Time complexity of this actual algorithm is this much time. N power A log power B N plus M power C log power D N. This is. Now can you help me compare both? I want, right? This is the actual answer. I want like this. How? I think everyone log N is there. Log n is there. So what should I do? Log n is there. I think if you want log n, B should be 1, right? I think A cannot be there. N cannot be there. N power 0. So A 0, B is 1. So that log n will come. That is okay. What about this one? M power C, log T power n. So I think M required, C is 1, D is 0, right? D is 0. If at all D is 1, log n will be there, D 0, right? Like this. So can you help? Finally, what is the thing is asking? A plus 10B plus 100C plus 1000D. 1000D. A 0, 10. What is the B? 1. What is the next one? 100. What is the C? 1. What is the, right? 1000. What is the D? 0. D0. Can you say total? 10 plus 100, which is going to be 110. Answer is 110. Whatever possible, right? I think most probably you got. Right. So please be careful. Right. Please be careful. Yeah, this question number is 12. It is belongs to ABL trees. Answer of this problem is going to be finally what is the answer? 110. It is a numerical problem. So what is the first step? Find L using ABL tree property. Worst case is log n. Afterwards, from L, apply in order, which will take M time, because from L, M elements only you are printing, so M time. Final time complexity is going to be log n plus M. Some people are asking, sir, why don't you take one person? I don't know who is bigger. That is the reason I written both. If you know one person is bigger, take. Some people are saying that, sir, log n is bigger. No one knows. Why? This M may be close to n, then it is bigger. Some people are saying that M bigger, right? So no one knows, because M may be from L to H, maybe only 2 elements are there. This may be bigger, may not be bigger. Whenever you have dilemma, take both. So this is the time complexity. So now he is saying it is the time complexity what we got. It is the time complexity according to him. Just map. So A0, B1, C1, D0. Then only I will get. So from this, right? A plus 10B plus 100C plus 1000D find out, which is going to be 110. This problem is given. Please be careful. 2014 also given. Last year GATE exam 2020 also given. Please be careful. Right? So can you help me for this problem? What is the answer? 110. I'm thinking that mostly you got whatever I explained. Mostly you got. If anyone didn't get, please check again. Please check. Rough idea I given. Right? Fine. This is question number 12. What is question number 13? Question number 13, let me explain now. Question number 13, what is the answer? I think to this one, right, what is asking is in the min heap or max heap, in the min heap or max heap where index is starting from 1, right? So to find out the parent of I, what is the answer? I by 2, right? I by 2 floor value, please check once, right? I think answer is going to be B. This one you know very well. That is the question number 13. Go to the next one, question number 14. Question number 14. We are already done. This problem is already there in your notes also. Smallest element at the root. Seventh smallest element can be found. What is the answer? D. See this one. Many places you are able to see this answer as log n. No, answer is not log n. Answer is, right, order of 1. Log n also correct. 1 also correct. Best answer is 1. So D is the answer. Question number 14. Answer is D. Right? Somewhere I seen this is the log n. Log n also correct. 1 also correct. Best answer is 1. Question number 14. Answer is D. Next one. Question number 15. Question number 15. What is that one? Minimum element in the max heap. What is the answer? Order of n. B. Question number 15. Answer is going to be minimum element in the max heap tree. Minimum element is not meant for max heap. Right? Minimum element is meant for min heap. But you want maximum. Still possible. One scan required. Answer is going to be option B. Question number 15. Answer is going to be B. Next. Go to the question number 16. Go to the question number 16. Yeah. See the question number 16. Question number 16. What is the answer? Right. I will explain to you. I will explain. Question number 16. I am starting now. Please take care. Right. I am starting. See this one. See everyone now. N elements are there. Question number 16 I am explaining. Please you take care. N elements are there. Listen, N elements are there. Whenever N elements are there, right? These N elements, left may be anything, right may be anything. Normally in the binary tree, a binary tree which contain N elements. There is a binary tree which contain N element. In that one, left may be anything, right may be anything. But what he mentioned in this problem, right? It is not a binary tree. See this one. In the normal binary tree, if total elements are n, left may be anything, right may be anything. But what is the problem? It is not a binary tree. It is a weight balanced binary tree. See this one. Weight balanced binary tree. Please be careful. He mentioned something special. In the n nodes binary tree, right? If you add some condition is mentioned, then it is going to be weight balanced binary tree. What is the condition? Let me check. Condition is going to be, right? A weight balanced tree is a binary tree in which for each node, the number of nodes in the left subtree is at least half and at most twice the number of nodes in the right subtree. Suppose assume that total nodes are n nodes, assume, right? In those n nodes, please be careful. In those n nodes, assume that, right hand side n by 2 nodes are there. Assume. Total n nodes, right hand side if you keep n by 2 nodes, can you say what the left is saying? The number of nodes in the left subtree is at least half and at most twice the number of nodes in the right subtree. What is the meaning? Right n by 2 is there, left should be either half of this. How much? N by 4 or double of this. Can you help me? It is a binary tree. A binary tree is said to be a weight balanced binary tree. Condition is right whatever you keep. Left should be, right, at least half of this or double of this. Can you help me now? Right n by 2. Left should be either n by 4. See this one, left should be, right, minimum is n by 4, minimum n by 4, maximum is double, means I think 2 into n by 2 n. Now again I am repeating now, in this binary tree which contain n nodes, if you keep right as n by 2, left should be minimum half of this. What is the meaning? N by 4. Maximum double of this. What is the meaning? N. So left to right whatever you keep, left should be minimum half of this, maximum double. What is the meaning? You can keep here n by 4 elements also. You can keep here 2 into n by 2 means n also. N by 4 also you can keep here, right? N also you can keep. But one thing, minimum n by 4, maximum n means what I mean? In between also you can keep. Boundaries he said, in between also you can keep. Total n elements. Right you kept n by 2. Left should be minimum half of this, maximum double of this. It doesn't mean that in between not possible. Minimum half, maximum double. Minimum half means what? N by 4. Maximum is what? 2 into n by 2 means n. So minimum n by 4, maximum is n. In between also okay. You can keep n by 2 also, no problem. In the binary tree with this condition is known as weight balanced tree. A binary tree in which right whatever you keep, left should be minimum half of that, maximum double of this. Then that binary tree is called as weight balanced binary tree. It is a weight balanced binary tree. What is the reason? Right whatever I will keep, left should be minimum half of that, maximum double, in between also okay. Yes, this is also weight balance. And one more, same story going on further also. Whatever I done in the top level, same thing going on further also. What is the meaning? Here n by 2, right, whatever you keep left should be either half or double. Isn't that right? Right is going to be n by 4. Left should be, what is the answer? Minimum half, n by 4 by 2. What is n by 8? Maximum double, 2 into n by 4 means n by 2. So like that. So whatever happening at the top level, same thing is going on. This is a weight balanced binary tree because it is satisfying the property. Some people are asking, sir, it is a weight balanced binary tree, it's okay. Then what is the height of this? You only say, right? If you observe clearly, always, right? Always divide by 2, by 2, by 2, by 2. If you see this tree, you will get the log n base 2 levels. The height of this one is log n base 2. Question number 16. Weight balanced tree definition is mentioned. Accordingly, I divided. I got to know the height of this tree is going to be always by 2, by 2, by 2. See, left also always by 2, by 2. Right also always by 2, by 2. So, I think height is going to be maximum level, right? Maximum if you see, left also log n base 2, right also log n base 2, maximum is log n base 2. Listen everyone now, this weight balanced binary tree, height is going to be log n base 2. Next one, some people are asking, this weight balanced binary tree height is log n base 2, that is okay, but only one weight balanced binary tree possible or many maybe? Let me check. One weight balanced binary tree I drawn, height I got to know log n base 2. Let me try one more weight balanced binary tree. See this one? See everyone? N nodes are there. Let me draw one more weight balanced binary tree. Right? N nodes are there. In those n nodes, if you observe, see this one. Right I kept n by 3. Right I kept n by 3. Can you say what is the left? It is a weight balanced binary tree where I kept the right n by 3 nodes. Left should be minimum half. What is the meaning? N by 6. Maximum double. What is that one? 2n by 3. 2 into n by 3. I am keeping maximum. 2n by 3. In this weight balanced binary tree, right n by 3. Left should be minimum half n by 6. Maximum double 2n by 3. I kept 2n by 3. Yes, this is also weight balanced binary tree. If at all it is also a weight balanced binary tree, please help me. Right? So, right if you see, always divide by 3, by 3, by 3. Can you say what is the right height? Log n base 3. Left is always, listen, left is always multiply by 2 by 3, which nothing but divide by 3 by 2. 2n by 3 can be written as n by 3 by 2. So, right is always divided by 3, left is always divided by 3 by 2. If you divide always by 3 by 2, 3 by 2, 3 by 2, if you see, left height is log n base 3 by 2. Always you are dividing by 3 by 2. Right height is going to be always dividing by 3, log n base 3. Can you help me now? Right height in this weight balanced binary tree, log n base 3. Left height in this weight balanced binary tree, log n base 3 by 2. Can you say which one is larger among these two? What is the answer? Log n base 3 by 2. So, height of this tree is going to be log n base 3. What is the meaning of height? Longest path. This path is log n base 3 by 2. This path is log n base 3. Height is nothing but longest path. Longest path in this tree, log n base 3 by 2, which is nothing but height of this. That is also weight balanced binary tree. What is the height? Log n base 2. This is also weight balanced binary tree. What is the height? Log n base 3 by 2. So, he mentioned the weight balanced tree definition. Accordingly, I drawn two weight balanced binary trees. One weight balanced binary tree height is log n base 2. One more weight balanced binary tree height is going to be log n base 3 by 2. But what is asking? Let's check here. What is asking? What is asking? Let's check here. The maximum possible height of such a tree on n nodes. You want maximum height. So many weight balanced binary trees may be there, but you want maximum height. I think that kind of weight balanced binary tree, log n base 2 height. This kind of weight balanced binary tree, log n base 3 by 2 height. Right? Let's check, is there anything else possible? Can you help me now? In the available option, if you see log n base 2, 1 height, that we are already got. Log n base 3 by 2, I think that is also we got. Can you help me now? A and D, which is the larger? Base is small means big number. The option A is base 2. Option D is base 1.5. Comparing A and D, who is better? D better. And one more, comparing C and D, who is better? Base 3 and base 3 by 2. I think 3 by 2 better. Comparing, I think C also, this is one. Log n base 3 also got. Here itself I got. Comparing this is better. So, comparing A, comparing C, comparing D, who is better? D better. Let's check B and D. Let's check B and D. Can you help me now? Forget about the B until now. A, C, D, who is possible? All possible. A, C, D, all possible. Among all of them, who is the better? I think D better because base is small, value more. So A, C, D, all three possible. So D is better as of now. I think B option is left out. Let me try for B also. Let me try for B. Let me draw the B. Listen everyone now. B purpose I am drawing one weight balanced binary tree. See this one. N nodes. Option B purpose. Second option purpose I am drawing one weight balanced binary tree. Let me draw. See this one. N nodes. See this one. N nodes. Can you help me one small line now? What the option B? Log n base 4 by 3. Means what is the meaning? Always divide by 4 by 3. Dividing by 4 by 3 is nothing but multiplying by 3 by 4. Right? I think left is going to be, listen, right is going to be 3n by 4. 3n by 4 is nothing but divided by 4 by 3. Assume that right is 3n by 4. Can you say what is the left? If right is 3n by 4, what is the left? Left should be minimum half, maximum double. If at all minimum half if I keep, then what is the answer? 3n by 8. This is going to be 3n by 4, right? So right is 3n by 4, left should be minimum half, maximum double. Half means what? By 2 you do. What is the answer? 3n by 8. Minimum half, maximum double. Double means what? Into 2. 2 into 3n by 4 is nothing but 2 into 3n by 4. 2 cancel, 3n by 2. I kept minimum. Minimum I kept. Can you help me now? Right is 3n by 4. Left should be half, minimum half, maximum double. I kept minimum. Minimum I kept. Can you help me now? Right is 3n by 4. Left you kept half of that. That's okay. Let me add 3n by 8. And 3n by 4. Let me add. I kept minimum. Right this much. Left should be minimum. Minimum is half. Maximum double. Minimum I kept. 3n by 8. 3n by 4. Let me add it. What is the answer? 8. 8 1s 8. 3n. 4 2s. I think 6n. Totally 9n by 8. Try to remember. Right. After keeping right this much. Left is I kept only half. After doing that. Total sum if I do. 9n by 8. What is the meaning? It is the more than n. Try to remember, 9n by 8 is greater than n. 9n by 8 is greater than n. You only say total is n elements. Total is n elements. Right? If I add the left and right, it is coming more than n. More than n means, but I have n nodes only. Please see this one. Of such a tree on n nodes is best described by which one of the following? Only n nodes are there. If only n, if I add left and right, how I got more than n? Try to remember that kind of right weight balanced binary search tree not possible. If you want to get the option B, right you have to keep 3n by 4 means left should be minimum, right? Half of these are double. I kept half only. After keeping half, if I add both, it is coming more than n. What is the meaning? I think such kind, right? With this story, weight balanced binary search tree not possible. I want to get the option B. I tried also, but I got to know it is coming more than n. More than n means don't take because I have only n nodes. So, can you help in a question number 16? Question number 16, right? So, what options are possible? A possible, C possible, D possible. Available possible things. Best one. Option D. What is the problem with the second option? Second option not possible at all. This may be, second option may be tempting. Why? Base 4 by 3, base 3 by 2. 3 by 2 means 1.5. 4 by 3 means 1.3. So, comparing the option B and option D, B is bigger value, but it is not possible at all. I tried also. For the second option purpose, I tried also because of it is a very small value. See, base small means big value will come. So, option B is big value because the base is small. That is the reason I tried. I got to know that kind of weight balanced binary search tree not possible. The reason is, right? So, if you do that kind of division, total sum is more than n. If more than n, only n nodes are there. How more than n possible? So, can you help me now? For the question number 16, right? Which options possible? A possible. C possible, D possible, B not possible. That kind of division not possible. Now, whatever is possible in that, which is the larger one? I think D. So, final answer is D. Please be careful. Now, some students are asking in the question number 16 what he want to ask. In question number 16 is testing you from your side. Right? Do you know? Do you know? Always divide by 2 means how many levels will come? Log n base 2. Do you know that or not? Next one, log n base 2, log n base 3, which is bigger? Log n base 2. Base small, big answer. These two only checking. Always divide by 2, log n base 2. Always divide by 10, log n base 10. Next one, log n base 2, log n base 10, bigger one, log n base 2. Why? Dividing by small number, many levels will come. These only is testing. For that, he added some condition. What is that one? Weight balanced binary system. So, for the question number 16, answer is going to be fourth option. Question number 17. In question number 17, see this one. See the question number 17. See the question number 17. In question number 17, if you observe clearly, what he is saying is having one BST. In that BST, he is trying to find out element 43. In question number 17, if you observe clearly, he is having a BST. He is not asking you construct BST. He is asking, he is having a BST. In that BST, he is searching for element 43. Then which one of the following probe sequences are possible, which are not possible? He is having a BST. In that BST, he is trying for element 43. Which probe sequences are possible, which probe sequences are not possible? You have to find out. Some people are asking, sir, what is the meaning of this? Let me try. See this one? Let me try. Before going to explain the question number 17, right, I am explaining one small thing. Please see this one. See, to explain the question number 17, right, I am explaining one small example. Afterwards, we will go to the question number 17. See this? It is a 50. It is a 10. BST means what? Left smaller, right greater. Next one. It is 80. It is a 90. It is a 100. Next one. It is going to be 70. It is a 75. It is 60. This one. It is a 85. Right, like that. It is a BST. See carefully now. There is a BST. This is the BST. Question number 17, I will explain within few minutes. To explain the question number 17, something required, I am giving one example. See, question number 17 purpose, one example I am writing. One example. See, one BST I took. Right? Question number 17 to explain, I took one BST. Yes, it is the BST. Can you help me now? In this BST, how to, listen, in this BST, I am searching for element 85. In this BST, I am searching for element 85. How? Let's check. Start from here. BST means left smaller, right greater. Please be careful. In this BST, I am searching for element 85. This is the way. 50 is equal to 85. No. First, whom I verified? 50. 50 is equal to 85. No. Then, what he will say? You want more? Go right. Again same. 80 is equal to 85. No. But what 80 is saying? You want more than me? Go right. Next one. 90 is equal to 85. We said no. You want less than me? Go left. Next one. 85 is equal to 85. Yes, stop. Yes, stop. Can you help me now? In this BST, to find out element 85, what are the elements you visited? 50, 80, 90, 85. These are the elements which I visited. This is called as probe sequence. In this BST, to find out element 85, this is the probe sequence I followed. This is the probe sequence. See, in this BST, to find out element 85, the path what I followed is these 50, 80, 90, 85. This is called probe sequence. For the element 85 in this BST, probe sequence is, this is the probe sequence. Please be careful. Listen everyone now. In this BST, to find out element 85, the path which I followed, 50, go right, 80, go right, 90, go left, 85 is equal to 85, stop. Right? This sequence, whatever you followed, that is called probe sequence. If you are really okay with this, now see the question number 17. Question number 17 I am explaining. Until now, to understand question number 17, the theory which is required I explained to you. Now question number 17 I am explaining. Read the question number 17. A binary search tree is used to locate the number 43. See this one. To locate the number 43, right, he is using one BST. This is the BST. He is not given, but he is using BST. Listen everyone now. To find out element 43, he is using one BST. He is using, but he is not shown to you. See, the example which I explained to you, I given BST. In that BST I am trying for element 85. But in this problem, he is using one BST to find out element 43. But that he is having BST, but he is not shown to you. He is not, but one thing, he is having BST. He is not showing to you. Can he help you now? In his BST, who can be root? Anyone. He is not showing to you, but he is having a BST. Who can be root? Anyone. Right, now see the answer. Now he is saying that in this BST, which he is having, you want to find out element 43. Now he is saying which probe sequences are possible, which are not possible. Let's try. Who can be root? Anyone. Who can be root? Anyone. Let's see. According to option A, who can be root? He got 61. Yes. In his BST, root may be 61. Who knows? So I asked this BST. So first one, what the option A saying? 61. I think 61 root may be possible. So he is asking. Now I am asking that person. 61 is equal to 43. Which you are trying for? 43. 61 is equal to 43. What he said? No. Then which side I have to go? Because of BST. Which side? I want 43. This BST contain root as 61. Which side I have to go? Go left. Left I went. When you went left, what is the next element you got in the option A? 52. Of course, less than 61, 52 possible. Now again I will ask. 52 is equal to 43. No. Which side I have to go? Go left. Left I went. What he got? 14. 14 I got. 14 is equal to 43. No. Which side I have to go? Go right. Next what I got? 17. 17 is equal to 43. No. Which side I have to go? Go right. 40. 40 is equal to 43. No. Which side I have to go? Go right. What is the answer? 43. So this is the order. So he is having a one BST, but he is not shown to you. So anyone can be root. According to option A, 61 is root. 61 is equal to 43. No. I want less than that. Next one what I got? 52. 52 is equal to 43. No. Less than that. 14 is equal to 43. No. More than that. 17 is equal to 43. More than that. 40 is equal to 43. More than that. 43 is equal to 43. Yes. Stop. Right. So that is the option A. Let's see the option B also. He is using one BST. Right. So let's see this one. Option B. So as soon as I started, 2 came. BST 2. Root as 2. Yes. It's okay. 2 is equal to 43. No, more than that. What is came? 3. 3 is equal to 43. More than this. Next one. 50 is equal to 43. Less than this. Next one. 40 is equal to 43. More than this. 60. 60 is equal to 43. No, less than that. But one thing. It is a BST. You only say in this BST less than 50. 40 came. That's okay. More than 40, 60 came, it's okay. But one thing, right? To this 50, these are left people. Left how 60 possible? It is a BST first of all. In this BST, less than 50, you came this side. This side, how will you get 60? So that there is an option B is false. Less than 50 you came. But how 60 possible? Less than 50, how 60 possible? Right? See, if you see normally less than 50, 40, but one thing, left of 50, whatever there are, all should satisfy. He failed. So option B failed. So to this problem, question number 17, to this problem, A no problem, please check. B problem, C also no problem, D also no problem, E having problem, verify yourself. B and E having problem. Some people are asking, sir, how E is having problem? Let's check here. Let's check. Root 17. You want 17 or 43? 43. More than that. Next. 77. You want 77 or less? Less. 27. You want 27 or more? More. 66. You want 66 or less? Less. You want 18 or more? More. Right? So 43, 43. See, if you see the diagram like this one, there is no problem. But observe clearly. See this one. Observe you only clearly. You only say, can you help me now? Listen everyone. When you come right, and see this one. 27 right when you come. 27 right you came. Right? Definitely all will be more than 27. See, how 18 possible? More than 27. Right means what? Greater. More than 27. How 18 possible? You only say. Some people are asking, sir, how you know? If you are unable to catch directly, check here. After diagram is over, see this one. After total problem is over, you check like this. How? Like this you can check. Some people are asking, sir, how to check? After diagram is over, you can check. See this one. All are more than 17, check. Yes, no problem. All are less than 77, check. All are more than 27, no, he is not. Like that you can verify. To this problem, A no problem, B problem, C no problem, D no problem, E is having problem. Question number 17, answer is going to be, he is asking, which of the probe sequences are possible and which are not. Right, this is the thing. That is question number 17 story. to question number 18. Go to the question number 18. Question number 18 is saying that this one. Question number 18 is saying that Tn be the number of different binary search trees on n distinct elements. Tn be the number of distinct binary search trees on n distinct elements. Then Tn is equal to something is given where x is, right? You have to find out x value. I think to find out number of binary search trees, one formula there. That formula is given. In that formula something is missing, right? That one we have to find out. How to do that. See this one. How to do that. Carefully listen. How to do that. See everyone. Number of binary search trees Tn is equal to this one. Sigma k is equal to 1 and n. Number of binary search trees k minus 1. Number of binary search trees, right, with x. This is the formula. Tn is equal to sigma k is equal to 1 to n t of k minus 1 into t of x, right? Now what I want to say indirectly, like see this one. With n nodes how many BSTs possible? Question number 18. With n nodes how many BSTs possible? Can you help in total nodes how many? N nodes. With n nodes, this one. With n nodes number of BSTs are Tn. With n nodes number of BSTs are Tn. Please be careful. With k minus 1 nodes number of BSTs are T of k minus 1. With x nodes number of BSTs are T of x. Please be careful. Now let me ask you one small, careful listen. If the total nodes are n, listen everyone, if the total nodes are n, out of those n nodes, one person is root, whoever it may be. Out of n nodes, one person is root, remaining n minus 1. Out of n nodes, how many, listen, with n nodes how many BST is possible, that's okay. Out of those n nodes, one person will be root, remaining how many? Remaining n minus 1. See this one. Out of n nodes, one person, whoever it is, one person is root, one root will be there, right? So out of n people, one root if you see, one root will be there, that's okay. Remaining how many? Remaining people are n minus 1. Remaining people are n minus 1. Those n minus 1 people, remaining is n minus 1. Those n minus 1 people divide into two parts, left side, right side. Total nodes are n. Out of those n nodes, one person is root, remaining is n minus 1. Those n minus 1 people divide into two parts. What is the one? Some people keep left side, some people keep right side. With the left, listen everyone now, with the left people, number of BSTs possible is TL, T of L. With the right people, number of BSTs possible is TR. With the n nodes, number of BSTs possible is Tn. So Tn is equal to left how many possible? Tn. Right how many possible? TR. Right, please be careful. See this one. M base possible left side, n base possible right side, both combined m into n base. Like that they are multiplying. This is left how many possible. This is right how many possible. After getting this one and this one, multiply, then you will get the total BSTs. With the n nodes, how many BSTs possible? T of n is equal to, out of them, 1 is root, remaining n minus 1. Those n minus 1 divided into two parts, few left, few right. And one more, left how many? All possibilities you have to cover. All possibilities means what? N minus 1 people, left how many? Sometimes keep 0, sometimes keep 1 node, sometimes keep 2 node. Every possibility you have to cover. So n minus 1 people divided into left and right. Left also cover all possibilities, right also cover all possibilities, then you will get the total BSTs. Now some people are asking, what is this k minus 1? Out of n people, k minus 1 people you kept on the left, x people you kept on the right, but one thing, if I add both, if I add left and right, if I add both, total nodes will come. So can you help me now? Left plus right, what is meaning? K minus 1 plus x, it should be equal to n minus 1 because 1 is root. Left how many people you kept? K minus 1. Right how many people you kept? X. Left how many BSTs? T of x. Right how many BSTs? T of x. Left how many BSTs? T of k minus 1. Again I am asking you. Left how many elements? Left how many nodes you kept? K minus 1. Left BSTs how many? T of k minus 1. Right how many nodes you kept? X. How many BSTs possible on the right? T of x. Total how many? This one into this one. Now can you help now? Total nodes how many? K minus 1 I kept left, x I kept right. By adding both, n minus 1 I will get. Not n because 1 is root. Left people, right people, if you add, you will get the n minus 1 because 1 is root. K minus 1 plus x is equal to n minus 1. Can you help me now? I want x value. X is equal to, what is the answer? N minus 1, right? Bring these two. Minus k plus 1. Plus 1 minus 1 cancel, remaining n minus k. So, x value is going to be n minus k. Please be careful. Right? So, question number 18. What is saying? What is the x value? N minus k. Which option? Second option. It is there in your notes also. Question number 18. It is belongs to formula of, this is the formula to find out number of BSTs for the given n nodes. For the given n nodes, to find out number of BSTs, this is the formula. How this formula came? Nothing there. N people, one root, remaining n minus 1. N minus 1 divided into two parts. Few keep on the left, few keep on the right. Right? Left how many you will keep? Left how many you will keep? Minimum 0. Some people are asking how 0? See this one. K value 1 if you keep, 0 will come. Next one, k is slowly increasing. K value 1, what is the answer? 0 will come. K value 2, 1 will come. K value 3, 2 will come. Like that, all possibilities. Left keep few, right keep few. By adding both, n minus 1 will come. What is the left range? Minimum 0. What is the right range? Minimum 0. Totally n minus 1 divided into two parts. Any one can be empty also. Left 0, remaining all are right. Left 1, remaining all are right. Left 2, remaining all are right, like that. Divide n minus 1 people into two parts because 1 is root. So, left plus right becomes n minus 1. Finally, find the x value, n minus k. This is the formula to find out number of BSTs. One more formula there to find out number of BSTs. This is 2n Cn by n plus 1. This is also will give number of BSTs for n nodes. This is for BST. It will give BST, and BST another name is going to be, right? One more name, unlabeled also. Unlabeled binary tree. Unlabeled binary tree and number of BSTs both are equal. Meanings may be different. Unlabeled means what? No labels are there. BST means what? Label is there, right? Left smaller, right greater. Here no label is there. So here label is there, here no label is there. That is the only difference. But how many BST is possible? Those many unlabeled possible. This is the formula for number of BSTs and number of unlabeled also. In unlabeled, no label is there. In the BST, label there, but left smaller, right greater. This is the only difference. Remaining all will be similar for both. Can you help me for this problem? Question number 17. Sorry, question number 18. What is the answer? Second option. Go to the question number 19. Go to the question number 19. Which one of the following array satisfies heap property? Sorry, max heap property. Max heap property. Something is given, max heap property. Everyone know. Right? Max heap or min heap will store inside computer in the form of array. Which is satisfying max heap property? Max heap means what? Root maximum. Root maximum. Let me try option A. 16. Next. 10. Next. 12. Next. 8. Next 3. Next 5. See, everywhere root maximum check. I think option A. Question number 19, option A. 16, 10, 12, 8, 3, 5. So question number 19, answer is going to be option A. Question number 20. Question number 20. Let me check the question number 20 also. There is a 3 array max heap. Is like a binary max heap, but instead of 2 children, 3 children. Now he is asking which one of the following is a valid, question number 20, which one of the following is a valid sequence of elements in array representation of 3 array max heap. 3 array max heap, 3 array max heap and binary max heap both are same. Binary max heap only 2 children, 3 array max heap 3 children. Let's check which is the max heap here. Max heap means what? Maximum element at the root. Let me check the option A, 1 is there, it cannot be. Right? Option B, let me check. 9 root, 3 children, 6 also, 3 also, 1 also. Next one, I think what is the answer? 8, 5, I think here fail. 8, 5, I think this one. Root should be maximum, but here not. So I think option B cannot be. Which option then? Let's try for option C. 9, 3, 6 and 8. Option C I am trying. Question number 20, option C. 9, 3, 6, 8. Next. I think 5, there is a problem. So option C also no, maybe option D. Let's try option D. What that one? 9, 5, 6 and 8. 3 and 1, of course. So question number 20, what is the answer? D. Question number 20, D. Go to question number 21. Question number 21. Let me try question number 21. What is the answer? Question number 21. So some elements are inserted in that order into valid 3-array maxi found in the question number 30, right? Right? See, in the previous problem, see this one. In the question number 20, whatever tree came, in the tree, 3 elements are inserted in that order. Order is important. Are inserted in that order into the valid 3-array maxi found in the question number 20. It is actually 20, it is not 30. Right? Let me try. See this one. 9, 5, 6, 8, 3 and 1. Let me insert one by one. First let me insert the 7. I am inserting 7. You know insertion in the min heap or max heap insertion, you know. See this one. I want to insert 7. Yes, I inserted. After inserting, ask parent any problem. Yes. Then what the answer? Swap it. 5 is here, 7. Afterwards ask, no problem. Can you send after completion of the 7? Next 2 I am inserting. I think no problem. Next 10. I think there is a problem. Here 6 there, here 10. Here 9 there, here 10. Next, after 10, next 4. Ask the parent, no problem. So this is the final answer. Let me write the final answer. What is the answer? 10. This is 7. This is 9. This is 8. What is the 7 story? 3, 1, 5. What is the 9 story? What is the 9 story? 2, 6, 4. Can you see in the array format what is the answer? 10, 7, 9, 8, 3, 1, 5, 2, 6, 4. Which option? 10, 7, 9, 8. I think only first option is match. Option A. For the question number 21, answer is option A. Right? Let's go to the next one. Question number 22. Question number 22. See the question number 22. To convert this binary tree into max heap tree, minimum number of interchanges how many required? Minimum number of interchanges how many required? Right? So I think what will you do is apply build heap method. Apply build heap method. Can you help in build heap method? Build heap method will do all the things at a time. Right? Let's check here. Build heap method will start from first non-leaf node. See this one. I am applying build heap method to convert this tree into max heap tree. Build heap method will start from first non-leaf node. See this one? First non-leaf. I think this. These are the leaf nodes. This is also leaf. It is the first non-leaf. Right? From here onwards, apply max heap if I top procedure. You know very well build heap method. Let's start. Max heap means what? Root is maximum. Root is maximum. Let me ask. You will ask both the children. Problem there. So what is the answer? When you say max heap if I top, what is the meaning? You will ask both the children whoever is maximum with that swap. We will come down only. Let's ask once. 10, 9, 70. So 70 is here, 10. One swap done. Next, I think this also. 12, 11, 6, no problem. This one, no problem. Right? I think this one. I think from the first non-leaf node onwards I started. From the bottom, first non-leaf node. This is over. Come here. 40, 72. So what is the answer? 70 here, 40. He will come down only. He came and he want to go further. I think no problem because root is max. I think one more. This one. 19, 17, 12. No problem. Next come here. 89, 19, 70. I think no problem. So how many interchanges? 2 interchanges. For the question number 22, answer is C. Just I applied build heap. To convert the given binary tree into max heap, how many minimum interchanges required? Minimum interchanges how many required? How many? 2. I think this is 1, this is 1. 2 required. Listen everyone, whatever answer I said, it is going to be wrong. Listen everyone, question number 22, answer is going to be apply build heap, number of interchanges required 2. Right? And one more, because of he is asking minimum, right? So answer I got 2, that's okay. If anyone say this answer is wrong, if you can prove it, less than 2 possible, then only it is wrong. Question number 22, answer is going to be build heap, right? 2 interchanges required. So in the question number 22, option is going to be C. Go to the 23. Question number 23. The number of elements that can be sorted. It is not stored, it is sorted. Please be careful. Question number 23. See this one. E return stored. It is not stored, it is sorted. Question number 23, it is sorted. Now let me read once again. The number of elements that can be sorted in theta of log n time using heap sort is. Listen everyone now. Using heap sort with theta of log n time, how many elements you can sort? Question number 23. Using heap sort with theta of log n time, how many elements you can sort? So now I am giving answer. See this one. Whatever you know about the heap sort, let me write. This question belongs to heap sort. Fine. In the heap sort, I know one small line. What is that one? See this one. In the heap sort, I know one small line. See this one. An element to sort. Careful listen. Heap sort. An element to sort, heap sort will take how much time? N log n time. This is the only line which we know. In heap sort, an element to sort which will take how much time? N log n time. This is the only line which I know. Using this line, I have to solve this problem. I am solving. See this one. An element to sort heap sort rule saying that n log n time required. N log n time required. Now see this one. See correctly. The question what he is asking, if you observe clearly, right? Theta of log n, see this one. An element to sort using heap sort n log n time, I am okay. The question what they are asking is, see this one. With log n time. With log n time. Using heap sort. Number of elements. See this one. With log n time. Using heap sort. Number of elements can sort. Assume x. See this one. About heap sort, I know only this. Now he is asking, with log n time using heap sort, how many elements you can sort? Assume x. With log n time using heap sort, number of elements can sort is assume x. Right? Can you help me one small line now? Right? So, using heap sort, x elements I can sort. Can you help me now? Using heap sort, if you can sort, listen, using heap sort, if you can sort x elements, how much time it will take actually? Using heap sort, x element can sort. Can you help me now? How much time it will take? X element to sort actually using heap sort, it will take x log x time. Using heap sort to sort x element, actually it will take x log x time. It will take this much time. This much time it will take. X element to sort using heap sort, it will take x log x time. If you want, you can take base 2 also. Right? X log x time it will take, which is equal to, according to his opinion, right? It is theta of log n. X element to sort using heap sort, it will take x log x time. But according to his opinion, it will take only log n time. Can you help me now? For which x value, both will be equal. X log x time to sort x people really required, but he is saying that that is log n. Which x value, these two will be equal. I will explain now. Right? I will explain. See this one. This time, right, is equal to theta of log n. Right? For which x value, I will try. See the options also given, it is very simple. Let me try option, right? Let me try option D. Let me try. If you try the option D, substitute one by one. If you try the option D, isn't that x is log n into log n. Log n into log n cannot be equal to theta of log n. So D cannot be. D cannot be. Next one. Some people are asking, what about root log n? If you keep x by root log n into log of root log n. Root log n into log of root log n. Then what is the answer? Root log n into log of root log n. It cannot be equal to log n. What about option A? Right? I think option B also I tried. No. What about option A? If you keep option A, that is 1. 1 into log 1. Log 1 becomes 0. It became 0. 0 cannot be theta. It is not big O also. Theta. Theta means what? Both the side equal. So what is the answer? A also cannot be. So what is the answer? Answer is C only. Some people are asking how. Let's check. X replaced by log n by log n. Next one. Log of x replaced by, what is the answer? Log n by log n. Right? This is equal to, see this one. This is equal to, see this one. Log n by log n. Now replace log a, log of a by b. Log a minus log b. What is the answer? log n minus log n. Right? I think everyone know log n, see log n minus log, right? Log n minus log n. I think everyone know it is a bigger, it is smaller. Asymptotically it is equal to, what is the answer? Log n by log n. This is becomes log n. Because everyone know n square minus n asymptotically n square. Finally, these two are cancelled. Finally, log n. See, left log n, right also log n. Answer is going to be C. It's a nice problem. Please take care. Question number 23. Answer is C. Some people are asking, sir, how? Right? Some people are asking, sir, how? See, I think very simple. This is the only thing which I know. See, heap sort. An element to sort, heap sort will take n log n time. Now he is asking, with log n time, how many elements you can sort using heap sort? Assume x. If at all x elements can sort, x element sorting will take heap sort x log x time. But that x log x is equal to log n is asking. Which x value? Both are equal. Replace x by option C. Right? Then asymptotically left and right both will be equal. So answer for the question number 23 is C. Right? Fine. Now go to the next one now. Question number 24. Question number 24. Question number 24. Right? So this is there in your notes also. Please try properly. For the question number 24, answer is A. Question number 24, answer is A. Now see the question number 25. Question number 25, if you see clearly, question number 25, if you see clearly, one array is given. To that array, you have to create max heap. But interesting thing is given, right? These numbers were inserted into the max heap in the given order. So you have to insert in the given order. You cannot do build heap here. Build heap method is coming to the picture when order doesn't matter. Necessarily in the same order. You can insert all the people at a time. Because of he is saying that inserted in the given order. Order is important. Means insert one by one. Question number 25 saying that one array is given. Create max heap to that array. How to create? You can insert one by one. You can do build heap also. But the thing what he is saying is you have to insert one by one. You have to insert one by one. Means order is important here. In the given order. Suppose if he given not necessarily in the same order. You can insert whatever order you want. Then you can go to build heap. Because of they are saying insert in the given order. So insert one by one, one by one by one. Question number 25. Create max heap for the given array by inserting one by one, one by one, one by one. Not build heap. Insert one by one. After doing that, see this one, after doing that, you got this kind of tree, this tree. You got this kind of tree. Right? This is the max heap. Now what is asking is, after creating max heap, right, for the given array, to that max heap, right, write in the post order. To that max heap, write the post order. Right? You will see post order afterwards. Right? Post order, pre-order, right? Definitely in the tree traversal you will see, don't worry. For the given, right, max heap, write the post order, right? Post order is there in the array where array index starting from 0. Now can you say in the post order format, write down. In the 0th place, post order 3 there. In the first place, 7 there. Second place, 10 there, and so on. In the post order, 10th place, 45 there. Now in the similar way, for the given max heap, right, the max heap tree whatever you got, write the level order traversal also. Level order, listen everyone now, level order is nothing but BFT, breadth first to traversal. That also you will see in the graph traversal, maybe in the next class it will come. So for the given max heap tree, draw the post order, yes I written, right, draw the BFT also, level order means BFT. So level order means nothing there, level by level store. In the first level what is there? 45. Second level 32, 6. Next level 10, 23, 1, 5. Level by level you write, which is also known as BFT. So I think after writing the level order BFT, 0th place 45 there, first place 32 there, second place 6 there, and so on. So for the given array I constructed max heap by inserting one by one. After getting the max heap tree, for that I written the post order, I written the level order, everything fine. Now can you help me now? In the post order 0th place who is there? In post order 0th place who is there? 3. Right? Next one, can you help me in the level order, where is the 3? In post order 0th place 3 there, that is okay. In the level order, where is the 3? In the level order, right? I think 3 there, which place? 7th place. In the post order, 3 there, 0th place. In the level order, right? 3 there in the 7th place. Can you see the difference? What is the difference? 0 minus 7, 7. So 3 difference in both the orders are going to be 7. In the similar way, in the post order, where is the 7? First place. Right? In the level order, where is the 7? 8th place. Right? 1 minus 8 is going to be, right? 7. In the similar way, for 10 also find out. Post order 10, second place. In the level order, where is the 10? Third place. 2 minus 3. Modulo is there. 1. Like that, for every person find out. Who is the larger one? Among all of them, larger one is 7. So, for the question number 25, answer is going to be 7. The only dilemma in the question number 25. This problem may be lengthy. Forget about all. Right? The only dilemma in the question number 25 is going to be, should I apply insertion 1 by 1 or build heap? Insert 1 by 1, because he is saying that inserted in the given order. Order is important. Insert whatever order you want, then you can apply the build heap. Insert in the given order. That is the twist here. So, just by inserting 1 by 1, apply, construct the max heap. Afterwards, do the post order and level order. For every element, indexes, see the difference, whichever is the larger one. Larger one may be 7, maybe 3 also 7, 7 also 7. Whatever it is, larger answer is going to be finally 7. Is asking maximum. What will be the maximum possible value of I minus j? Right? For the question number 25, answer is 7. Right? Fine. Question number 26. Question number 26, answer is going to be B. Question number 26, answer is B. Question number 27, question number 27, D. Question number 27, answer is D. What is that one? None of these. The reason is, you will get this kind of tree. If you draw the tree for the given information, you will get this kind of tree. Some people are asking, sir, how to draw the tree? What is the answer? Binary search tree, post order is given. Binary search tree means everyone know, right? By default, in order is going to be ascending order. So, in order is given, post order is given, you can draw the tree. After tree construction is over, if you verify, it is not max heap, it is not min heap, it is not strict binary tree also. What is the meaning of strict binary tree? Everyone should contain 0 child or 2 child. Here 1 child there. So, question number 27, answer is going to be D. What is the reason? It is not min heap, it is not max heap, it is not strict binary tree. How to draw the tree? In order is given and post order is given. You post order will give the root, in order will give the left subtree, right subtree. Right. Go to the question number 28. Question number 28 you go. The worst case running time, the worst case time complexity to search for an element in a balanced binary search tree. Everyone know. Balanced binary search tree, insertion will take log n, deletion will take log n. Right? Next one, searching also will take log n. N elements log n. Here how many elements are there? Log 2n factorial elements are there. N elements log n time. 2n factorial elements are there. Log 2n factorial. So, in the ABL tree, what is the meaning of balanced binary search tree? ABL tree. In the ABL tree, insertion time, deletion time, searching time. Insertion time, deletion time, searching time. Right? This will take log n time. Log n time. N elements log n. Here how many elements are there? 2n factorial. Log 2n factorial time it will take, which will goes to log of 2n factorial. What is the upper bound? 2n whole power 2n. Which will goes to 2n log 2n. Forget about constant. What is the answer? N log n. 2n log 2n. Forget about constant. So I think n log n. For the question number 28, what is the answer? N log n. B is the answer. Please check properly. 2n factorial upper bound. 2n whole power 2n. Which is nothing but 2n log 2n. Which is nothing but n log n. For the question number 28, answer is going to be second option. It is related to ABL tree. ABL tree, insertion, deletion and searching time log n for n people. Log n for n people. Log n for n people. 2n factorial people there. Log of 2n factorial. So, 2n factorial upper bound, 2n power 2n, which is going to be 2n log 2n, asymptotically n log n. Answer is B. Right. See the question number 29. This problem I already covered in the classroom note. See, classroom notes also I already covered. The answer for this problem is going to be the number of comparisons is asking. The number of comparisons is asking. Answer is B. Question number 29. Already we covered in the classroom also. Let me read the problem. Consider the process of inserting an element into max heap, where the max heap is represented by an array. Suppose we perform a binary search on the path from the leaf to the root to find the position of the newly inserted element. The number of comparisons performed is B. Log n. Question number 29 already there in your notes. Please check. Question number 30. Question number 30. So n elements are there in the min heap. You want to insert n more element. Need not be one after another. What is the meaning? At a time you can apply build heap. Build heap n people n time. Now build heap on 2n people 2n time, which is nothing but order of n. B. Question number 30. B. Go to the question number 31. Question number 31. Question number 31, if you see, two statements are given according to Bellman code algorithm. Which statement is right, which statement is wrong, we have to identify. P. Always finds a negative edge weight cycle if one exists. Need not be, because sometimes may not be reachable. Find whether any negative edge weight cycle reachable from the source. Yes. P is false, Q is true. So what is the answer? He is asking which one of the following statements are correct. What is the answer? I think Q only. B. P is not correct, only Q is correct. Q only. B. Question number 33. So he is asking Dijkstra's algorithm time complexity using sorted linked list data structure and adjacency list. Dijkstra's algorithm time complexity using sorted linked list data structure and adjacency list. Sorted link, right? Sorted linked list. Please be careful, and adjacency list also. So can you help if you do that, Dijkstra's algorithm, sorted linked list you are using in the place of the min heap, and one more, in the place of the input, you are using the adjacency list. Can you help what is the left cost? Left cost, what is the answer? Always finding minimum. What is this one? It is a sorted linked list. What is the answer? Constant V. That is the left cost. What is the right? Adjacency list you are using. So adjacency finding E time. That is okay. But what about decrease key? E decrease key operations, it's okay. What is every decrease key operation? Will take V time. Because it is a sorted, you have to adjust also. This is for left side deleting minimum. Because of it is already sorted. Every time is constant. This is adjacency finding, adjacency list E. Next one, after finding adjacency decrease key operation, every decrease key operation because of it is a sorted linked list, you have to scan back, right? What is the answer? V time. Sorted linked list data structure. So I think EV. So finally V plus E plus EV. So what is the answer for this problem? Answer is going to be order of EV. Answer is order of EV. Question number 33. Using sorted linked list data structure, adjacency list EV. Go to the question number 34. Question number 34. Answer is going to be. What is question number 34? Dijkstra's algorithm, single source shortest path. We run from a compute the correct shortest path distance from 2 to. What is the answer? Answer is D. For the question number 34, answer is D. Question number 35. I think question number 35 and 31, I think both are looking like same. So I think answer is B. Go to the question number 36. Question number 36, if you see, two statements are given about the Bellman-Ford algorithm. They are asking which statement is right, which statement is wrong. So check properly, right? For this problem, answer is going to be B. Answer is B. Next one, question number 36, answer is B. Question number 37. Question number 37, a graph contains negative weight edges. Then which one of the following is correct when we run Dijkstra's algorithm? Answer is B. Dijkstra's algorithm always will terminate because of a negative. It may produce wrong also. It may produce wrong answer. Question number 37, answer is B. Question number 38. Question number 38 is belongs to Dijkstra's algorithm, right? If you take S as source and if you apply Dijkstra's algorithm, what will be the answer he is saying? So what he is saying here? To go from S to T in this directed graph, to go from S to T, what will be the shortest path? And one more. While doing Dijkstra's algorithm, right? While doing Dijkstra's algorithm, strictly greater comes, then only change. Otherwise, don't change. See this one. See the question number 38, second line. There are multiple shortest path between vertices S and T. Which one will be reported by Dijkstra's shortest path algorithm? Assume that in any iteration, the shortest path to a vertex V is updated only when a strictly shortest path to V is discovered. Means strictly smaller one is coming, then only change while doing the updation, right? You know what is the meaning of, what is the name of that updation? Decrease key operation. While doing decrease key operation, strictly smaller coming, then only change, otherwise don't change. Suppose this condition not there, right? Assume that in any iteration, the shortest path to a vertex V is updated only when the strictly shortest path to V is discovered. If this line is not given, then what will you do? Smaller coming, then you can update. Equal also, you have chance of updating. Small coming, then change. Equal is coming, then also if you want, you can change. You may say that, sir, equal, why should I change? You may say like that, right? If you change even though equal, if you change, right? Then what the answer is? Same answer only you will get. Path may be different. But you don't want, right? New paths. Old path only you want to continue. What is the meaning? Same thing coming, don't change. Means old things only I will continue. Strictly smaller, then only change with that condition. Simple. I am repeating again now. Question number 38. Dijkstra's algorithm starting from S for all the people finding shortest path. But his goal is S to T. What will be the shortest path? But while doing this algorithm, strictly small coming, then only change. Otherwise, don't change. That is the only condition. Right? So if you do that one, question number 38, answer you will get a D. Please check. Right? To go from S to T, the shortest path is going to be S to A to C, C to E, E to T. This is the path. S to A to C, C to E, E to T. This is the shortest path. Question number 38, right? Because of some assumption is given, little bit change there. Otherwise, exactly same algorithm. He is not asking Dijkstra's algorithm vertex selection. That sequence is not asking. To go from S to T, shortest path with this condition, what will be the shortest path? Question number 38, answer is D. Go to question number 39. Question number 39, one graph is given, one directed graph is given, and what he is saying is this one. Suppose that you are running Dijkstra's algorithm on the edge weighted directed graph below, starting from vertex A. Means on the given graph, on the given directed graph, starting from vertex A, he applied the Dijkstra's algorithm and he got the answer also. See, he already applied, he got the answer also. Table also given. What does the table contain? If the source is A, right? If the source is A, what the distance contains is 1. A to A, cost of the shortest path is 0. A to B, cost of the shortest path is 2. A to C, cost of the shortest path is 13, and so on. Parent and everything is given. Everything. Now he is asking, right? Listen everyone now. Graph is given and outputs also given. The only thing is, right? From this graph, from this graph to get this table, right? What are the missing values of X and Y? You have to find out. Suppose nothing is missing, right? Graph is given, table is given. What is so great in that? Graph is given, in the graph some X and Y there, right? So from this graph, he constructed one table also. Everything is fine. Then he is asking find the X and Y values. Find X and Y values, right? We will do now. See this one. See everyone. Our goal is X and Y only, not all the things. Some people what they are doing is, on the given graph, again they are applying Dijkstra's algorithm. No. Graph is given and Dijkstra's algorithm he applied, he given answer also. Table is nothing but answer. Now, from this table, listen everyone now, from this diagram to get the table, from this diagram you got already the table. To get that table, what are the possible values for x and y, we have to calculate. You no need to apply Dijkstra's algorithm again. Please be careful. Let's see this one. Let's see a, right, a, and the remaining also is one. I think some graph is there. Necessary things only let me write. A, right, some graph is given. If really required, I will write E. E already done. We no need to do anything. From the graph, E already got the answer in the form of table already available. From the graph, to get that particular table, find the x and y possible values. Right? We will see now. I will explain. G and H. This is 4, this is y, this is x, this is 29, it is 18, right? Now next one more thing, see this one. From this graph, he applied the Dijkstra's algorithm and he got the answers also. What are the answer table values? Let me write. He is not asking apply Dijkstra's algorithm. He is saying that on the given directed graph starting from A, I applied Dijkstra's algorithm. I got the answer also which is shown in the form of table. Then find the possible values for x and y. That is the thing what he is asking. He is not asking you apply Dijkstra's algorithm again from starting. If at all if you apply Dijkstra's algorithm again from starting, then why he is given the table? Then what way you are using the table? Please be careful. Some students are applying Dijkstra's algorithm again on the given graph. No. Graph given, Dijkstra's algorithm he applied, he got already answer. Now from the graph to get the table, what are the possible values for x and y is asking. Your concentration should be x and y only, not the Dijkstra's algorithm and all. No need to apply again from starting. Right? No need to apply again from starting. And one more, he got already answers also. Let me see the table now. Let me see the table. So previous things required major because of your concentration is x and y. Concentrate those values only. X and y related values only. Let me concentrate. Can you help me now? Right? So x and y. Now can you help me now? He already got the table. He already got the answer. Go to the table and check. Go to the table and check. Can you help me now? What is the E dot distance? What is the E dot distance? 11. E dot distance, see the table. E dot distance is 11. What is the parent? F. Right? He got best answer. To go from source to E, best answer is 11. He got already. From F he got. Go to the F also. See the table. F also. To go from source to this person, right? Best answer he got as of now is 7. From where he got? B. Next one, go to the G also. To go from source to G, best answer already he got 36. Right? Distance is best answer. Parent is F. Next one, I think H also he got. See this one. To go from source to H. To go to source to H. Right? Already he got the best answer. How much? 19. Distance is 19. What are the parent? E. He already got the answers. Please be careful. He already got. I am thinking that everything is absolutely fine. Right? Now see this. See carefully. Now see this one. From the source to E, already best answer 11. From where he got? F. Next one, from the source to F, already he got the best answer 7. From where he got? B. Somewhere B is there. Before that B is there. Next one, from source to G also he got the best answer 36. From where he got? F. That is fine. Now next one, from source to H also he got the best answer 19. From where he got? E. Right? That is the story. Now listen. Now he is asking x value, y value, how will you find out? Now you only say, to come to H, how many possibilities? To go from source to H, best answer I want, that is okay. To go from source to H, best answer I want to find out, it's okay. Best answer it's okay, but to come to the H, what are the possibilities? Right? From F also you can come, from E also you can come. Two ways are there. To go from source to H, right? So either you should go to OIF or OIE. But one thing, what is the interesting answer? From the F also you can go to H. From E also you can go to H. But one thing, Dijkstra algorithm is over. He already got answer also. How much he got? He already got answer as 19. To go from source to H, he already got the best answer as 19. But from where he got? From E he got. from E he got. Can you help me one small line? You only say to come to H two ways are there. F also you can come, E also he can come. But according to Dijkstra's algorithm, he already done. From where he got? From E. Can you help me now? E value already 11. How much you have to add so that I will get 19? What is the answer? It should be 8. 11 plus 8, 19. To come to the H two ways are there. E plus X also one way. F plus Y also one more way. But the Dijkstra's algorithm already completed, right? He got the answer as 19 from E. He already selected this only. Comparing Y path, X path, listen, to come to the H, comparing Y path, right? X path only better according to Dijkstra. That is the reason he selected already. Now can you help me now? Already E value 11. 11 plus something is going to be 19. How much it is? It should be 8. Now let me ask you one small line now. To come to the H, one more path also there. What is that? 7 plus Y also one more possibility. One possibility is 11 plus X. One more possibility is 7 plus Y. 11 plus X is 19 means X should be 8. That's okay. Next one. F plus, listen everyone, F is already 7. 7 plus Y is, 7 plus Y is, 7 plus Y, even though 7 plus Y is there, but he taken 11 plus 8 only is taken. What is the reason? I think 7 plus this Y, either it is equal to 19, 7 plus Y is equal to 19 or more than 19. That is the reason, see, supposing that 7 plus Y, if less than 19, he could have selected the 19, 7 plus Y is less than 19, he could have selected this path only. For the 7 by adding Y, if answer will come less than 19, he could have selected this path only. But he selected this path. What is the meaning? This path may be, total sum is either 19 or more than 19. More than 19. Can you help me now? Can you help me now? What is the minimum value you are expecting here? Minimum value. What is the answer? It may be 12. It may be 12. 12 also, listen everyone now. 12, this is also 19, this is also 19. Whenever two equal things are there, you can take whatever you want. If two equal things are there, you can take whatever you want. Right? It is also 19, it is also 19. You can select whatever you want. So, this is 19, right? If it is 19, because of 219, you can select whatever you want. So, can you help me know what are the Y possibilities? Either 12 or more than 12. What is the X? X is only 1, 8, that is okay. Y should be either 12 or more than 12. Please be careful. More than 12 also, because of more than 12, suppose that is the 15, 7 plus 15, what is the answer? 22, but it is the 19, that is the reason he selected. Suppose that it is the 10, 7 plus 10 is going to be 17, at that time he will select this only, why he will select this. Can you help me now? What are the possibilities for X plus Y? What is the answer? X value 8 confirm. What is the Y? Y may be 12 or more than 12. What is the answer? 8 plus 12, which is going to be 20. So X plus Y should be greater than or equal to 20, either 20 or more than 20. Either 20 or more than 20. Please be careful. He is not asking in this problem apply Dijkstra's algorithm. What he is saying is, I have a graph, I applied Dijkstra's algorithm on the given graph, I got the answer. Already answers also given. Now, from the given graph to get these answers, right, find the possible values for X and Y. Possible values for X and Y is going to be X plus Y greater than or equal to 20. This possibility is either 12 or more than 12. You cannot say 13 here. You cannot say 13. What is the reason? Whenever two equal things are there, you can take whatever you want. And if he mentions some condition, if you want, you can check. In the question number 38, one condition is there. What is that? Assume that in any iteration, the shortest path to a vertex V is updated only when a strictly shortest path to V is discovered. If the condition like that is given, then same thing is coming, don't update something like that. Because of no condition, nothing here. What is the answer? Right? So, there is a chance that both will be equal. If both are equal, you may say that, sir, how he selected this path? Whenever both are equal, you can take whatever you want. Right? So, he is taken this one. So, the possibilities here, you cannot say it is a 13. Minimum is 13, you cannot say. Maybe 12 or more than 12. The possible values for X plus Y is going to be greater than or equal to 20. Please be careful. Question number C is one. Question number 38. Question number 39. It is a nice one. Please take care. Question number 38 is saying that apply Dijkstra's. Question number 39 saying graph given. He applied Dijkstra's. He got the answer. Already answers also given. But from the graph to get the answer, some values are missing. Find the possible values for X and Y. Don't apply Dijkstra's for the question number 39 because he is already done. What you want to do again? Some people are asking, sir, I will do Dijkstra's. I will do Dijkstra's myself from starting. right? Somewhere the given table and the Dijkstra's algorithm what you applied, both are not matching. If both are not matching also, whatever he is given, you have to select. He will give whatever way you want, please be careful. He is saying that I applied Dijkstra's already, I got this answer. He is not asking verify, you are applying Dijkstra's answer, I have applied the Dijkstra's answer, both the answers verify. He is not saying. For the given graph, I applied Dijkstra's, I got these answers. So, to get these answers from the given graph, what are the possible values for x and y? You have to do that. So, answer is going to be x plus y greater than or equal to 20. Can you help me for the question number 39? What is the answer? Greater than or equal to 20 is the answer for this. 39 answer is x plus y is greater than or equal to 20. Go to the question number 40. Question number 40, let's go to the question number 40. One graph is given, is asking, find the number of edges which are not included in any of the shortest path from node G. From node G to every other vertex find the shortest path, that's okay. But in those shortest paths, if you observe, some edges may not participate. Some edges may not participate. He is asking how many edges are not participating. Answer is going to be 4. 4 edges are not participating. Question number 40. On the given graph, if you apply Dijkstra's algorithm by taking source as G, right, from the G to every vertex find the shortest path, right. If you find the shortest path from G to every vertex, in that shortest path some edges will not participate. So, how many edges are not participating is asking. 4 edges are not participating. So, I will, if you want to see this one, see the answer also. G, A, M, you know Dijkstra's algorithm very well. T, and E, see this one, and E. So from G, Dijkstra's algorithm you apply this one. If you apply this one, this side is 2, best answer. To go from G to A, 2. To go from G to M, 5. To go to G to T, 3. To go to G to E, 3 plus 4, 7. These are the shortest path. To go from source to every vertex, these are the answers. G to A is 2, please check, less than 2, no chance. G to A, 2 best answer. G to M is 5 is the best answer. Some people are asking, sir, I will go G to T, T to M, then 7 will come. If you go G to M, 5 is better. If you want to go G to T, 3 better. If you want to go to G to E, right, if you go via A, 2 plus 7 is going to be 9. But if you go via T, 3 plus 4 is 7 only. So, from G to every other vertex, these are the shortest paths. Some people are asking, sir, how you got? I applied Dijkstra's algorithm. In question number 40, on the given graph starting from G, if you apply Dijkstra's algorithm, from G to every other vertex, you will find out the shortest path. Now, can you help me now? From G to every vertex, you find out the shortest path, it's okay. Can you help me? In all these shortest paths, if you observe, which edges are not participating in the shortest path? What is the answer? I think this edge is not participating. See, this edge is not participating. This also not participating. This also not participating. This also not participating. I think 4 edges. The white color things whatever I written, these edges not participating in any shortest path from G to any other vertex, right? Shortest paths if you observe, these 4 edges are not there. Question number 40, answer is going to be 4. Now go to the next one. Question number 41. Question number 41 is asking how many disjoint spanning trees in a complete graph with n vertices. Right? How many disjoint spanning trees in a complete graph with n vertices? Listen everyone now. Listen everyone. Right? See this one. Number of spanning trees in Kn is equal to. Number of spanning trees in Kn is equal to. What is the answer? N power n minus 2. Listen, what is the meaning of Kn? Complete graph. Complete graph with n vertices. Number of spanning trees are n power n minus 2. Right? Next one. See this one. Number of spanning trees in K4. How many? Number of spanning trees in K4 is equal to 4 power 4 minus 2. Right? 4 square. What is the answer? 16 spanning trees possible. K4 contains 16 spanning trees. K4 contains 16 spanning trees. Let me draw one small example. See this one. K4 contains 16 spanning trees. K4 contains 16 spanning trees. Now see this. Now see. See correctly now. 1, 2, 3, 4. It is the K4. K4 contains 16 spanning trees. Can you help me now? It is the K4, it's okay. This K4 contains how many vertices? 4. K4 contains how many vertices? 4. How many edges are there? 6 edges. K4 contain 4 vertices and 6 edges. How many spanning trees possible? 16. How many spanning trees possible? 16. Let's see here. Let me draw one spanning tree. K4 contain 16 spanning trees and 4 vertices and 6 edges are there. Let me draw one spanning tree. Let me draw one spanning tree. See everyone now? Let me draw one spanning tree. Can you help me one small now? Is it spanning tree or not? One spanning tree I written. For the K4, 16 spanning trees possible. One spanning tree I written. Can you help me now? K4 contain how many edges? K4 contains 6 edges. I drawn one spanning tree. Can you help me now? This spanning tree contain how many vertices? Spanning tree means all vertices should be there. How many edges? 4 minus 1, 3 edges. Now listen now, it is a one spanning tree, it's okay. Like that, how many spanning trees possible? 16 possible. But see the interesting answer. 1, 2, 3, 4. Careful listen. 1, 2, 3, 4. One spanning tree I drawn, it's okay. 1, 2, 3, 4. And one more thing I want to ask. In the given graph, how many edges? 6 edges are there. In the given graph, 6 edges are there. I drawn one spanning tree. In this spanning tree, already 3 edges I used. In this spanning tree, out of those 6 edges, 3 edges I already used. Can you help me? Remaining edges. I don't want to use these edges. I want to use remaining edges. Who are those? Totally 6 edges. Out of those 6 edges, I took 3 edges. I draw one spanning tree. Now I want to draw one more spanning tree without taking the previous edges. Already 3 edges I took. Without taking those edges, I want to draw one more spanning tree. Let me ask you, what is the answer? I think if you observe clearly, these edges he didn't use, right? Next one, I think this also he didn't use. So this is also spanning tree. See, for the K4, it is also spanning tree, it is also spanning tree. But what is the difference? In these two spanning trees, if you observe, no edge common. No edge common, right? What is the meaning of edge disjoint spanning tree? Edge disjoint. Joint means something common. Disjoint means nothing common. No edge common. Try to remember. See this one. For the K4, 16 spanning trees possible. For the K4, 16 spanning trees possible. In all those spanning trees, some edges may be common. 1 or 2 edges may be common. But now see what I done. For the K4, I drawn 2 spanning trees. Right? But if you observe the relation between these two, no edge common. These are called as edge disjoint spanning trees. This is called as edge disjoint spanning trees. No edge common. It's edge disjoint. For the, listen everyone now, for the given graph K4, normally 16 spanning trees. Now he is asking, I don't want all spanning trees, I want only edge disjoint spanning tree. What is the meaning? No edge common should be there. I think everyone now. Totally 6 edges, if you keep 3 edges here, remaining is 3, only 2 possible. K4 contain only 2 edge disjoint spanning trees. Can you help me now? K4 contain how many edge, let me write now. Edge disjoint spanning trees. In K4 is equal to what the answer? 2. I think if you observe clearly, K4 contain only 2. It is something like this one, by 2. Right? 2. So some people are asking, K4, because of 4, 2 got, you done 4 by 2. Right? What about 5 is given? What about 5 is given? Now nothing there. Right? Take, I think, if at all odd number, take the K5 and draw once again. No need to give proof. For everything, if you keep on trying proofs, right? Try to remember, in GATE examination, if you keep on giving the proof for everything, time is over. You should be so intelligent, right? See, not only doing correct time, do correct things. You want to do proofs and all, right? Before exam, you do. If anything new will come, listen, if anything new will come, please don't try to give proofs in exam. Right? By taking one small example like this, you can do. Right? I think if you see the problem also, see the problem? See this one, if you see the problem also, options are given asymptotically, mathematically. Indirectly is saying, take one example and please check. Question number 41, Kn contain how many edge disjoint spanning trees? See the option. Options are indirectly giving signal, mathematically given. What is the meaning? Substitute the values. Some people are asking, right? So how I know edge disjoint spanning tree? You know spanning trees. Edge disjoint spanning tree. Okay, no edge may be common. If you take the normal spanning tree, some edges may be common. All cannot be common. Some edges may be common. But here, no one will be common. Let me check here. Right? It is a one spanning tree. Let me draw one more spanning tree. Different spanning tree means something should be different. All need not be different. Something should be different. It is a one spanning tree. Let me draw one more spanning tree. See this one? Let me draw one more spanning tree. It is also spanning tree. It is a one spanning tree. It is also one more spanning tree. Some people are asking, sir, how can you say both are different? See this one. In this spanning tree, if you observe, this edge is not there, but here there. Some difference. So here some edges may be common. See, these two are not edge disjoint spanning trees because this edge common. This edge also common, but some difference is there. So these are going to be different spanning trees, but these two, if you observe, these are edge disjoint spanning trees. Edge disjoint spanning tree, what is the meaning? No edge common in the spanning trees. The spanning trees, whatever you drawn in that, no edge common. That is called edge disjoint spanning tree. Suppose, isn't that edge disjoint spanning tree condition not there? Condition not there. Everyone can give. K4 contain how many spanning trees? Everyone will give. Right? But when he kept some condition, you have to think little bit. Take one example and check. How you know example you have to check, right? By seeing the option. Okay, mathematically take one example and check. Some people are asking, sir, is there any chance of vertex disjoint spanning trees? Right? Not possible, because when you say spanning tree, all vertices should be there. So in one spanning tree I kept all vertices. In the next spanning tree I cannot keep any vertex. It is not possible at all. In one spanning tree I kept few edges. In the next spanning tree, other than those edges I have to use it. That is called edge disjoint spanning trees. Anyhow, for the question number 41, answer is going to be n by 2. K4 I took. I got 2. So 4 by 2, 2. I think option only C matching. No one is matching. That is the reason I stopped it. Suppose two options are matching. I will take one more. I will try. I will take one more. I will try. If some people are asking, sir, what about odd number? What about odd number? Take one example and check. Maybe floor, maybe ceiling. Just take one example. If really needed, I could have done. Really not needed. For the question number 41, answer is going to be C. Go to the next one. Question number 42. Question number 42. Question number 42. Let's see this one. Question number 42, one graph also given. Question number 42, one graph also given. Let's see this one. To the 9, 2, 15, 6, 4. How many edges I drawn until now? Question number 42 contain 6 vertices, it's okay. But how many edges I written? Only 5 edges I written. 1, 2, 3, 4, 5. Next one. Listen everyone now. Listen everyone. In this graph 6 vertices are there. 5 edges I written with edge weights. 5 edges I written with edge weights. But this graph contain how many edges? In this graph I written as of now 5 edges with edge weights. But actually how many edges are there? One more edge is here. One more edge is here. One more edge here. Totally 5 plus 3. This graph contain totally 8 edges. This graph contain actually 8 edges. But out of them 5 edges are given with edge weights. Remaining edges, edge weights not there. Right? Now something is given about this problem. You can read it. What is that one? The graph shown below has 8 edges with distinct integer value. See, nowhere repetition there. Right? 8 edges are there with distinct edge weights. Next one. The minimum spanning tree MST is of weight 36 and contain the edges AC. So what he is saying is, for this graph if you construct MST, in that MST whatever edges are there, right? Those edges are given with edge weights. So the edges the 5 edges which are given with edge weight, they are part of the MST. But actually this graph contain 8 edges. Only for 5 people edge weights given. For 3 more people edge weights not given. Edges given but edge weights not given. And one more, 5 people to whom edges given, edge weights given. They are part of MST for this graph. And one more thing, he mentioned one more thing also. The minimum spanning tree cost also is mentioned. How much? If you add all those 5 edge weights, right? 36 you will get. Please check. 9 plus 2, 11. 11 plus 15, 26. 26 plus 10, 36. So finally let me repeat now. One graph is given. In that graph totally 8 edges are there. Out of those 8 edges, 5 edges with edge weights is given. They are part of the MST. 3 more people, edges are given but edge weights are not given, they are not part of MST. And one more, distinct edge weights. Means same edge weight you cannot repeat again. 15 there, again 15 you cannot write. Like that it is given, that's okay. Next one, what is the MST cost? 36. That is also okay. Now he is asking the edge weights of only those edges which are in MST are given in the figure, right? That's okay. Next one, the minimum possible sum of weights of all 8 edges is asking. MST contain 5 edges, total sum is 36, it's okay. But now you want 8 edges, total sum how much? Possible minimum value is asking. Total 8 edges, possible minimum value is asking. Right? So 5 people sum is 36, it's okay. But you want 8 people sum. If at all exactly not possible, at least give minimum. That is the thing what he is asking. Let me see the last line. The minimum possible sum of weights of all 8 edges of this graph is 5 people sum is 36. He is asking 8 people sum. If 8 people sum is, right, many answers possible. He is asking give minimum possible sum. How to do? I will give the answer. It is very interesting problem. How to do this one? I will give the answer. See this one? This edge weight I have to find out. This also I have to find out. This also. See, I will give the answer. See this one? I think MST you know. This is the MST. Right? Let me check. These 3 people edge weights I will find out. Now see this one. Listen now. Any question is given. Any question is given in the GATE examination or any examination related to MST. Any question is given in GATE examination or any competitive examination related to MST or related to some graph where missing edge weights you have to count. Missing edge weights you have to find out. X value in this graph, find the X value. In this MST and find the missing edge weights. If at all, this problem should be, listen, whatever I am saying now, it is related to MST only. In GATE examination or any competitive exam, in GATE exam or any competitive exam, MST question is given. So that problem is related to MST. And one more, in that problem, he is asking find X value, find Y value. If any question is like that. Right? So whatever I am saying, that is belongs to only MST only. One graph given. He is saying that MST I want to find out in that graph. Then find out. Right? X value find out in that graph. Y value find out in that graph. Anything is given like that. What you do is, you want to find out here, 3 people, right? So then it is a MST problem. 3 people, whoever is 3 people, not given, you have to find them. How will you find? Very simple. Listen, very simple. First of all, without thinking those, 3 edges are missing, without thinking those. First of all, construct MST. He himself is given MST. You want to find out 3 edge weights, minimum possible sum of all 8 edges you want to find out, it's okay. So indirectly, directly, 3 people you want to find out. So MST, 3 people missing, those people you want to find out, that is okay. Then the approach is going to be, this is the approach. Please remember this one from now onwards. MST, missing people you have to find out. This is the approach. What we will do is, first to construct MST. By God grace in this problem, MST is already given. First to construct MST. Don't think about what you want to compute. Don't think about that. First to construct MST. With the given information, first to construct MST. Yes, I constructed. After constructing, listen, after constructing, given graph contain 8 edges. Out of those 8 edges, these 5 only part of MST. But actually 8 edges are there. Right? So 3 more people are missing. Why they are not part of MST? You will get to know what is the reason for that. See this one? I think this is the answer. See this one. First to construct the MST. Yes, I constructed. After constructing MST over, now see this one. Now I want to find out this edge weight. Let me ask you one small line now. This is already MST, right? Now listen. Because of this edge is there. Add this edge also to MST. It is already MST. Add this edge also to MST. Then what will happen? Already it is MST. To that MST you are adding one more edge also. But when you add one more edge, compulsory cycle will come. Because it is already MST, means n of edges are already there. If you add one more edge unnecessarily, guarantee cycle will come. Some people are asking, by adding this one, guarantee cycle will come because of the MST, that is fine. If cycle will come, why you deleted this only? Why not other people? What is the reason? In the MST is not there. What is the meaning? By adding this one while constructing MST, cycle is came. If by adding this one while constructing MST, if cycle will come, why you deleted this only? Why not these two people? What is the reason? I think he is the more. He is more. MST means minimum cost. By adding this one, unfortunately cycle came, they deleted this. If at all by adding this one, if cycle come, right, instead of deleting this one, you could have deleted this, but these two people are better than this person. That is the reason they deleted. What is the meaning? Right? These two people are better than this person means, can you help me now? What will be the possible value here? They deleted this means this person is larger. That is the reason they deleted. Can you help me? What is the possible value here? Everyone now. In the available people, who is the maximum? 9. It should be what is the answer? It should be 9 or more than 9. But one thing, right? Distinct given in this problem. What does it mean? 9 cannot be 10. Minimum possible value, minimum. You can write 20 also. By adding this one, cycle came. So I have to delete. But why you deleted this only? Why not these? These are better people. I cannot delete, right? So this is not better. That is the reason I deleted. How you know this is not better? It is not there in the MST means he is not better. Some people are asking, sir, this is 9. This is also maybe 9. But in the problem is mentioned distinct there. So same thing you cannot repeat. So what is the answer? 10. Now one more interesting question I want to ask. While writing 10, carefully listen. While writing 10, please check is 10 already available or not. Please check. Because distinct keyword. Actually I want to write 9. 9 is there here. So distinct 10 I written. Check 10 is there available at anywhere. If 10 is available at anywhere, you cannot write. You have to write 11. 11 is also there. Yes, assume. Then 11 you cannot write 12 like that. Distinct should be maintained. Now once again I am asking you, I want to find out this edge weight. So what will you do? Any MST problem, some edge weights are missing. If you want to find out, this is the approach. First thing is going to be, right, create MST first. Given information, create MST. After MST construction over, now go to your edges and do this one. What is the answer? Add this one, cycle came. If cycle came, delete him. Now he is asking, why are you deleting me only? Why not other? I will simply say that comparing other people, you are the bad one. That is the reason I am deleting. So there may be chance of equal also. Because of distinct, equal, no chance. So 10 I written. So this edge weight should be 10. Please be careful. That is the reason I deleted. Next one, one more. See this one? This edge weight also I want to find out. By adding this one, cycle came. If cycle came, why you deleted? This is the larger than these two people. I think who is the larger here? 6. It will be 7. Next one. Add this also. There is a cycle came. See this one. Cycle came. If you want, you can take this cycle also. I think 2 cycles are there. With these 2 cycles, one cycle is this. Right? One more cycle is this one. Right? Anyhow, in this cycle, who is the larger one? 15. Right? I think it will be 16. Right? In this cycle, who is the larger one? So here 2 possibilities are there. Please be careful. If you don't do that, if you do this one first, only this cycle. After this, if you do 2 cycles are there. This is also one cycle, this is also one cycle. Anyhow, it is not our problem. Whatever is given, we are doing. And one more, this order will affect, right? If you keep this one, right, 2 cycles will come. If you remove this one cycle only there. Anyhow, there is no effect. That is the reason is given. Can you help me in this cycle? Larger one, 15. Right? It should be more than 15, 16. After writing the 16, please check, is there any 16 there? No. So finally, what is the answer? 36 is already MST cost. Plus 3 people you added. Right? 10 plus 7 plus 16. What is the answer? 10 plus 16, 26 plus 7, what is the answer? 33. Finally, what is the answer? 36 plus 33, which will goes to? Check properly. Already 36 there. Plus 10 plus 16, 26. 26 plus 7, 33. Which will goes to 69. Right, 69 is the answer for this problem. Question number 42. All the 8 edges, total sum they are asking. How much? 69. Is it a minimum or maximum? Minimum. It is a minimum. Minimum value of all these edge weights sum. What is the answer? 69. 36 is already existing. One more 33 extra came. Who are those? 10 plus 7 plus 16. 10 plus 7, 17. 17 plus 16, 16, 16, 32 plus 1, 33. So 36 plus 33, which will goes to 69. So you have to create, listen everyone, any MST problem is given. Indirectly, directly, you have to use the cycle concept. By adding cycle, by adding this one cycle is coming. So I don't add. Why you don't want to add? Because of is larger, I don't want to add. Please use that technique. Please use that technique. Question number 42 is a nice problem. Please take care. Normally, any problem is given related to MST. Some edge weight is missing if you want to find out. First to construct MST. Afterward, try for your requirement. Question number 42, that is the answer. Answer is what? 69. Is it minimum or maximum? Minimum. Some people are asking if it is the maximum. Maximum means infinite also, because here I can keep 1 lakh also. Here I can keep 20 lakhs also. Here I can keep 30 lakhs also. So maximum they don't ask. Minimum they are asking. So 69 for the question number 42. Right. Right, now go to the next one. Question number 43. Question number 43. So what is the answer? Question number 43, you know answer very well. See. Next one. Question number 44. Question number 44. What is the answer? B. Verify yourself. Simply MST creation only. Next one. Question number 45. Question number 45. One graph is given. He is asking if you construct MST for that graph. Right? What is the cost of the MST? Right? Let me do this one. Nothing there here. Let me do here. Question number 45. What will be the answer? Let me check. If you create MST. Can you help me? How many vertices are there? A, B, C, D, E. 5. Next. G, H, I, J. A, B, C, D, E, F. 6 people. Afterwards 4. Totally 10 people. This graph contains 10 people. Question number 45. MST cost they are asking. Let me do once again. Let me do here. Yeah. Question number 45. One graph is given. They are asking, to this graph, if you create MST, what will be the cost they are asking? Let's do once, very simple it is. Let's do. Can you help me now? Which is the first minimum? I am applying Kruskal algorithm. First minimum. What is the answer? A to C. Next one. Second minimum. 1 is over. Second minimum 2. What is the one? E to I. It is the undirected graph. No directions also. E to I. How much? 2. First minimum is over, second minimum is over. Is there any second minimum again? I think one more 2 is there. What is that? C to D. That is also 2. Is there any one more minimum? B to G also. B to G also. Let's check this. Is there any 1? Is there any 1? Only 1 is there, it's okay. How many 2's are there? I think it is the 1, 2. What is that one? C to D, that is okay. One more. E to I, 2, that is also okay. One more. B to G also 2, that is also okay. One more is there. A to D also. A to D, cycle, don't add. Right? Don't add. That is okay. I think 2's. I think all 2's are completed. Check. Right. Next, let's go to the next one. 3. What is the 3? B to D. B to D. Is there any other 3? 1, 3 I took. Next one. Is there any one more 3? Please verify. One more 3. No. Go to the 4 now. What are the 4? H to I also. 4. Is there any one more 4? H to F also. Is there any F until now? No. H to F also. Let me write. 4 also. 2 4's are there, that is completed. Is there any one more 4? No. Let's go to the next one now. 5. What is the 5? J to I. J to I. It is the I. Is there any J? No. J to I. Let me write now. J to I. What is the value? 5. Can you help me? This graph contain, let me check how many vertices. A, B, C, D, E. Next one F. Next one is going to be G, H, I, J. Right, like that. I, J. That's it. Right. I think all vertices are there. But one thing, graph is still disconnected. So we have to continue further. 5. Can you see? Is there any one more 5? Is there any one more 5? No. Is there any 6? No. 7. No. Is there any 8? Yes. What is that? A to E. Please check now. So it is a connected one. Right? Connected one. Let's add all the things. Let's add all the things. We got the MST creation, everyone now. Yes, add all of them. 2 plus 3, 5, 5 plus 2, 7, 7 plus 1, 8, 8 plus 8, 16, 16 plus 2, 18, 18 plus 2, 22, 22 plus 5, 27, 27 plus 4, 31. Total sum is 31. So for the question number 45, answer is D. D or C? B. For the question number 45, answer is 31, which is going to be B. 45, answer is going to be B. Right? Fine. This is everyone now, only for namesake I done. Right? Fine. Let's go to the next one now. 45 is over. Go to the 46. Question number 46. This problem already we done. It is there in your notes also. Question number 46, answer is D. Go to the question number 47. Go to the question number 47. It is the manual checking only. Question number 47, manual checking only. Manual checking only. Question number 47. Right? Now see what the question number 47 saying is, right? See this one. To go from vertex 1 to vertex 2. To go from vertex 1 to vertex 2. Right? So you want minimum cost. What is the minimum cost to go from vertex 1 to vertex 2 in such a way that, see this one. What is the minimum possible weight of a path P from vertex 1 to vertex 2 in this graph such that P contains at most 3 edges. 1 to 2 path, listen, I want to go from 1 to 2, I want path P. That path P contain at maximum 3 edges, maximum 3 edges. You want to go from 1 to 2, so that path name is assumed that P. So you want P in such a way that, right, so maximum 3 edges should be there. So one edge also okay in this path, 2 edges also okay, 3 edges also okay. So one length paths you cover 1 to 2, 2 length paths also you cover, 3 length paths also will cover, among all of them minimum. To go from 1 to 2, find a path P such that that path should contain maximum 3 edges, and one more, it should be minimum weight. To go from 1 to 2, find out a path P in such a way that that path P contain maximum 3 edges, and one more, cost should be minimum. Right? Let's try. What is the answer? 1 to 2. See the graph and talk. I think because of they are given vertices number 0, 1, 2, 3, 4. First row is 0, next one is 1. So can you help me? 1, 2, 2. 1, 2, 2, how much? Columns also 0, 1, 2, 3, 4. Rows also 0, 1, 2, 3, 4. Can you help me? 1, 2, 2. What is the answer? Direct answer. 1, 2, 2 is 12. Directly if you go, 12 will come. You want to go from 1 to 2, right? So that you have to find out one path P in such a way that P contain maximum 3 edges. Cost should be as minimum as possible. If you go 1 to 2 directly, see this one. One length path, 12 came. Let me go 1 to 2 via some other vertex. So that I will get the 2 length paths. 2 length paths. Can you try? 1 to 2 via some vertex. 1 to 2 via some vertex. But I want the less cost. If you go directly one length path, 12. If you go indirectly by some vertex, what I will get? Let's check. Can you help me? 1 to 0, how much? 1 to 0 is 1. Next one, 0 to 2. 1 to 0 is 1. Next one, 0 to 2, 8. How much came? 9. So, one length path is 12. 2 length path is 9. I think comparing this one, this is better. Let's go to the 3 length path. Manual checking, I am not doing anything. Manual checking only I am doing. Let's see this one. 1 to 0. 1 to 0. How much? 1. Next one, 0 to 4. Check. 0 to 4, how much? 4. Next one, 4 to 2. 4 to 2. 3. So I think this is 8. So 3 length path is 8. My goal is I want to go from 1 to 2 only. He is asking maximum 3 edges you can use. If I use 3, 8 I got. If I use only 2, 9 I got. If I use only 1, 12 I got. Can you say best one? To go from 1 to 2, find path P. Find path P such that P should contain maximum 3 edges and one more, P cost should be as minimum as possible. Maximum 3 edges means what? 3 also you can use, 2 also, 1 also. So because of maximum 3, many ways are there. 3 length you can go, 2 length you can go, 1 length also you can go. 2 length may be many possibilities. 3 length also many possibilities. Among all of them, best one, I got 8. If anyone say my answer is wrong, if and only if you can get 7, please check. For the question number 47, to go from 1 to 2, find path P in such a way that P should contain maximum 3 edges and P cost should be as minimum as possible. So I got 1 length is 12, 2 length is 9, 3 length is 8. If anyone say this answer is wrong, please prove it less than 8. What is the meaning? 7 in the option, 7 there. 7 if you can give, then this answer is going to be wrong. So I am thinking answer for this problem is going to be 8. So question number 47, answer is 8, means second option B. Question number 47, answer is going to be second option B. This is only manual checking. 46 already we done in the class. Go to the question number 48. Question number 48, nothing there, right? Just to take one numerical example and check. V1, V2, V3 and so on, V5. Take one numerical example and we'll verify. I think because of options are given mathematically, substitute. You will get the B as the answer. Question number 48, B. Go to the question number 49. Question number 49, answer is D. This is there in your notes also. Go to the question number 50. Question number 50. Question number 50, if you observe, right, both the statements are going to be wrong. Question number 50, if you observe, suppose that average edge weight for a graph G is AABG, then the minimum spanning tree of G will have weight at most n minus 1 into AABG, where n is number of vertices. Next one. Statement 1 saying that let T be a minimum spanning tree of graph G. Then for any two vertices U and V, the path from U to V in T is the shortest path from U to V in the graph. Statement, see, question number 50, statement 1 saying that, right? So minimum cost spanning tree will give between two people shortest path. If it is the case, then why Dijkstra's algorithm? Why all pair shortest path algorithm? Please be careful, right? Minimum cost spanning tree goal is covering all vertices with the minimum cost, not between two people minimum cost, covering all people with the minimum cost. Because both are looking like minimum, some people are thinking that statement 1 is true. No. Minimum cost spanning tree and shortest path, no relation. Both are looking like this. 90% may be common. Looking may be like that, but no relation. Don't bring any unnecessary conclusion. If anyone say first statement is true, then why Dijkstra's? Why Bellman-Ford? Why all pair shortest path? Please be careful. 2. Statement 2 saying that some unnecessary relation is bringing, no relation at all. So 50, both the statements are wrong. What is asking? Which of the following statements are true? Answer is D. 50D. 50D. Next one. Question number 51. We done in the classroom also. Please verify. Right? Fourth option. Question number 51, fourth option. Next one. Go to the question number 52. Go to the question number 52. Answer is A. This also we done in the classroom. Please check. Similar kind of problem maybe we done. But anyhow, this is very simple only. Question number 52. Answer is A. Go to the question number 53. Go to the question number 53. This is also small problem only. I think whatever we done. So in the minimum cost spanning tree in the classroom, many problems we done. These are the practice problem. Please check yourself. Question number 53, B is the answer. Next one, question number 54. 7 is the answer. Question number 55. Question number 55, we done previously, MST problem, one problem we done. Like I think, let me explain. Like question number 42, this question number 55 also almost similar. Question number 42, whatever happening, question number 55 also almost similar. If you want, I will do that. See the question number 55. It is also nice one. Let me try this. Question number 55. Suppose that minimum spanning tree of the following edge weighted graph contains the edges with weights x, y and z. So one graph is given, right? I think the graph is, you are able to see this one. One graph is given. To this graph, if you create MST, for the given graph, if you create MST, in that MST, XYZ should be there, he is saying. One graph is given. To that graph, if you create MST, in that MST, XYZ should be there. Then he is asking, what is the possible value for X plus Y plus Z, he is asking. Because of he is saying it should be there. Don't try to keep XYZ directly. Forget about XYZ. For the remaining people, create MST. After creating, try to keep XYZ, guarantee cycle will come. Then try to do the same kind of story like previous. 55, 42 similar. Not only that, any MST problem, edge weights are missing. Right? Like this you have to follow. If you want, I will do it. Will take only few minutes. Let me try this one. A, B, C, D, E, F, G and H, I and J. So one graph is given, right? So to this graph you have to create MST. But one thing is saying, to this graph if you create MST, in that MST XYZ should be there. Because of he said should be there, don't keep them directly. Lastly we can keep. Assume that XYZ not there. Now start. Assume that XYZ not there, start the MST creation. Can you say first minimum? First minimum AG 1. Second minimum IJ 1. I think ones are over. Go to the 2. Forget about XYZ. Ones are over. Go to the 2 now. 2. What is the answer? CD. Next one. Is there any one more 2? No. 3. HI. 3 also completed. Is there any one more 3? No. 4. GH. Next one. Is there any one more 4? No. 5. EJ. Is there any one more 5? If there, we will add the nothing there here. 5. Next one. Is there any 6? Yes. Is there any 7? Cycle. Don't add. Next one. Is there any 8? BH. I think no cycle. See. Is there any 9? DH. Cycle. Is there any 10? And one more. Still it is not connected. What is the reason? Here. I think somewhere here. Can you help now? 10? No. 11? AF. So it is the MST. If you want, you can verify. 12 is CH. After 11, 12. Not needed. Is there any before 11? Before 11 anything is missing which I didn't use? 8 BH I written. 9 DH cycle. So this is the case. So for the given graph I constructed MST. This is the MST. Now what is saying? In this MST XYZ should be there. Let's go now. Now let's go to our actual story. XYZ should be there. Let's go to the XY. XYZ. Go to the X now. Where is the X here? Listen, it is the X. It is the X. So I want to keep this one. But when because of it is already MST, if I keep the X, what the answer? Cycle came. If cycle came, you have to delete this person. But he is saying that X should be there. Even after adding this one, cycle is came. I want to delete, but problem saying that he should be there. If at all he should be there, right? Comparing these two people, it should be less. Then only I can keep. Can you help me one smaller now? Less means how much I can keep. He should be there means comparing these two people. It should be minimum. So what is the answer? It is 11. I can keep here 10. I can keep here 10. I can keep here 5 also. I can keep here 6 also. But one thing, he is asking minimum value, maximum value. Maximum value. Maximum value I can keep 11. Because nowhere he is mentioned distinct also. Please check. In this problem, nowhere he is mentioned distinct. So I have to keep here. I have to keep here less. By adding this one, cycle is came. So I have to, because of cycle I want to delete. But he is saying that it should be there. So I decided to keep. But when you want to keep, you have to delete this. So you should be less than that. I want to keep 10. But 11 also possible because nowhere distinct. Maximum value is asking. So 11. So then you can delete. Next one, can you go to the Y? Where is the Y? X I completed. Where is the Y here? See this one? Y is this. By adding this one, Y. What is the answer? Cycle came. By adding this one, Y, cycle is K. If cycle came, right, why are you deleting here? He is saying that it should be there. Then you have to delete someone else. Whom I will delete? Larger one, this one. It should be 6. Next one, what else? Z. I think Z is here. What is that one? BC. I am adding here. By adding Z, once again, what is the answer? Cycle there. Right? If at all cycle, I don't want to write, but he is saying it should be there. But can you help me in the cycle, which is the larger? 8. Right? I think it is 8. It cannot be there. So can you help me? X plus Y plus Z. What is the answer? So I think maximum values I am keeping. These are the maximum values or minimum values? Maximum values. Minimum value minus infinite, minus infinite, minus infinite. So what is the answer? 11 here. Y. 6 will be here. Can you say Z? 8 here. So what is the answer? 11 plus 6, which is going to be 17. 17 plus 8. What is the answer? I think 17 plus 3, which is going to be 20 plus 5, 25. So for the question number 55, answer is going to be 25. 55, answer is going to be 25. Please take care about the calculations and all, but logic is this. Question number 55, question number 12, listen everyone now. Question number 55, question number 42, both are same. There is saying that XYZ cannot be there. Here XYZ should be there, he is saying, but procedure is same. Whether he will say it should be there, whether he will say it should not be there, just construct MST without them. Lastly, try to keep them, depending upon his requirement, adjust. And one more, take care about distinct is there or not there. Because of he is asking maximum value this much, minimum, right, minus infinite. Question number 55, answer is going to be 25. Please take care about calculation. 11 plus 6, 17, 17 plus 8, 25. 55, answer is 25. See the question number 56. One graph is given, is asking how many MST is possible for the given graph. One graph is given, is asking for the given graph how many MST is possible, right, using prims or Kruskal, any one. Let me use the Kruskal. Any algorithm, okay. Let me try. See this one. A, B, C, D, E, and F. Right? Now see this one in this graph, right? I think many may be possible because of lot of repetition. Let's see this one. First minimum 11. First minimum purpose only one possibility. Next minimum 12. Next minimum 12. See, until now there is no chance. See, all came. First minimum 11. Second minimum is going to be 2 12s. You can take this first, you can take this next. If you change also, it's okay because both are came anyhow. Right? It doesn't matter which order you will take. First minimum 1, no fighting. Second minimum fighting there. If you take this first, next he will come. If you take this first, next he will come. But anyhow, no different MSTs will come until now because anyhow these 2 12s are there. First minimum 11, next minimum is 12, 2 12s, both came inside. That's okay. Can you help me now? So, first minimum, second minimum, third minimum, it's okay. Next one, if you observe clearly, right, next minimum is going to be 13. So many 13. See this one. You can take this 13 also. You can take this 13 also. You can take this 13 also. You can take this 13. I think almost like 4 13s are there. 4 13, out of those 4 13, see this one. I think I need only 2 edges. 4 13s are there. Out of them I want only, right, 2 13s only I want. What I can take? See this one. This 13 and this 13 I can take. Next one. This 13 I can take. Next one. This 13 I can take. Right? Next one. This 13 I will take and this 13 I can take. But one thing, this 13 and this 13 I cannot take because cycle. Can you help me now? How many 13s are there? 4 13s are there. Out of those 4 13, 2 13s only you can take. Can you help me now? Out of 4 13s, only 2 13s you can take. How many ways? 4 C2. How many? I think 4 into 3 by 1 into 2. How many? 12 by 2. Which will go, I think 6 ways are there. Out of these 4 12, see this one. Out of these 4 13s, only 2 13s I can take. Right? 6 ways possible. But one thing is true. In those 6 ways, listen, in those 6 ways, if you take this, and listen everyone now, out of those 6 ways, if you take this first, followed by this one, cycle will come. Other than that, because of cycle you have to neglect. This is the only case cycle possible, remaining cycles no chance. So what is the answer? Totally out of 4 13s, taking 2 13s, 6 ways possible. Out of them, this way you can neglect. This way you can neglect. Totally 5 possible. Totally 5 possible. Find out, see, out of these 4, 4, 13, 13, 13, 13, 13, 4, 13. Out of 4, 13, 2 13s only I can take. So 4 C2 means 6 ways. Out of those 6 ways, these 13s, these 2 13s you have to cancel it. Remaining all possible other than this. So can you help in how many MST is possible? 5 possible. Some people are asking, can you draw them? I will draw. If you want, I will draw them. See this one. I think 6 ways actually possible. Out of 4 13, selecting 2 13, 6 ways possible. But 1 way is going to cycle, so I don't take. See this one. I am writing all of them. Right? 13 and 13. 1 MST. Next one. Let me write roughly. This is the one which already available. 11, 12, 12. One more is going to be this one. 13, 13. Right, one more. Because of you know already answer, 5 will come. Right, how? Just I am giving rough diagram. 11, 12, 12. This also. Next one, but if you observe clearly in all these MSTs, right, this I think middle 13, see, this I think cross 13 not there. I will use that also. See this. This 13 confirm, this may be one more choice. So totally 5 ways. So for the question number 56, one graph is given, he is asking for the given graph how many MST is possible? 5 possible because many times 13 is repeated. So even though 12 repeated 2 times, no problem because both came. But 13 repeated 4 times. 13 repeated 4, problem here is 4 I cannot take, only 2 I can take. Out of 4, 2 only I can take because I want only 2. Out of 4, selecting 2, 6 ways. But right, whenever I select out of 4, 2, 6 ways, one of the way creating cycle. Just neglect it, remaining is 5. So you may not believe that there is all the 5 diagrams I written. So for the question number 56, answer is going to be 5. 5 MST is possible. Next one, go to the question number 57. Go to the question number 57. So if you see the question number 57, right, it is a normal problem only. Answer is going to be 995. Please check. 995. Right? Some people are asking me, sir, how? Already for the given graph, MST cost is 500. For the given graph, already MST cost is 500. That graph contains 100 vertices. 100 vertices means in the MST, 99 edges will be there. Now what he done is, for every edge, right, he added extra weight by 5. So 99 times 5 will be there. If it is 100, 100 into 5 is 500, but here 99 times only 5. So what is the answer? 495. Which will goes to 995. Please check if anything wrong. 100 vertices are there. So, right, 99 edges only you want. For every edge, right, now he added 5 extra. The weight of minimum span, next, see this one. When the weight of each edge of the G is increased by 5, the weight of the minimum cost spanning tree, previous 500 plus, for these 99 people, 5 added extra. So 99 into 5, which will goes to 995. Question number 57, answer is 995. Calculate properly. What is the question number 58? Question number 58, answer is 5. It is very simple problem, you please verify. Question number 59. So answer is going to be A. It is also a small problem, please check. Question number 60. Answer is going to be B. This one we are already done in the classroom. Question number 61. Question number 61, C. This is also a small problem. Go to the question number 62. D. Go to the question number 67. 62, next one 63. Question number 63, A. Go to the question number 64. So approximate answer is D, approximately, not exactly approximately, because existing answer may not be there. Actual answer may not be there, closest answer is D. Whatever we done in the classroom, 3 examples may be done, similar way you do. Question number 64, D is the answer. Next one, go to the question number 65. Question number 65, 267. It is the normal only. Take 2 minimum, 2 minimum, 2 minimum. You know merge algorithm also, 2 minimums you have to take. Go to the question number 66. Right, he is asking linear search average case. What is the answer? D. This is there in your notes also. Go to the question number 67. It is a normal problem only. Please verify. D is the answer. Please verify. I still remember D may be the answer. Verify. This problem everyone know. We done in the classroom also. Question number 68. Please verify. This may be right. I still remember D is the answer. If you want, you can check one time. Right? Please let me know if anything is wrong. Go to the 68. Because nothing great I am not doing. Go to the 68. Right? C is the answer. Right. Go to the question number 69. Answer is going to be 4. B is the answer. If anyone asks you question number 69, how B is the answer? Right? Let me check here. See this one, this is the way. See this one, this is the way. So, I took one room. This is the one room. Right? Please be careful. This is the one room. Can you see in this room, who came first? A, listen everyone now. Right? A activity started. AS means started. In this room, activity A started. Next to activity B started. But one thing is true. In this room already activity A started. Until activity A over, second person cannot come. In this room activity A started. Because if it is not over, you cannot keep the B. Right? In one room, one activity only planned. Please be careful. So if some people are asking, sir, where it is? If you want, you can see this one. I think from the last third line or fourth line. See this one? An activity can be scheduled in a room only if the room is reserved for the activity for its entire duration. It is started, it should end. Until that time, it only there. So, I think A started. Next one, B also starting, one more room. Next one, C also starting, one more room. Next one, A is ended. Activity A ended. Then, this room is free. Next one, D started, because of it is free, you can use it. Next two, C is over, it is also free now. Next one, E is over. So, sorry, E is started, it is free, you can use it. Next two, F is started. See this one, I think all are full, one more is required. F started. Next one, B over, this is free now. D over, this is free now. G started, you can use anywhere. E completed, this is also free now. F completed, this is also free now. H started, yes. G completed, this is also free now. H also completed, this is also, I think 4 rooms required. For the question number 69, answer is going to be B, second option. Go to the question number 70. Question number 70, simply knapsack problem. Answer is B. Verify. Go to the question number 71. It is a normal problem only. Please read carefully. It is a dynamic programming. Somewhere 2 choices. Right? You do both, take minimum from them. 2 choices, what are those? Either one step or shortcut. By using shortcut, you can jump somewhere. 2 choices are there. Can you help me one small and assume that I am at the 10th place, right? You can go to 11th place or what he mentioned, one more shortcut also, right? In particular from 9 there is a shortcut to 15, 9 to 15. How much you have to add? From the 9 to get the 15, how much you have to add? I think 7. So wherever you are from there you can go one step extra or 7 you have to add. From 9 you can go to either 10 or you can go to 7. You can go to 9 plus 7. What is the answer? 15. 2 choices are there. Now can you help me? What is the answer? T of 9. Right? So is equal to what is the answer? 1 plus minimum of 1 plus minimum, you want minimum answer finally, 1 plus minimum of, what are the answer? 2 possibilities. T of 10, you can go one step. From there you can calculate. One more, T of, what is the answer? 15. He himself mentioned, from 9 you want to go to 15. So can you help me? It is the x, it is the y. Is it xy or yz? Yz. It is the y, it is the z. Now he is asking what is the yz value. What is the answer? I think 150. Please check carefully, it is a very simple problem. Using dynamic programming. Dynamic programming means what? Whenever choice there, do both. Minimum of, do both, minimum of them take. Some people are asking, sir, how to calculate? Again 2 choices. 1 plus, again 2 choices. It is also 1 plus, again 2 choices. That's what the dynamic program everywhere, right? This kind of behavior. So anyhow, question number 71, answer is 150. Next one, T1. T1, I think T1, how much time it will take to compute the out degree of each vertex? I think adjacency list, out degree. So for the vertex A is adjacency list, you have to scan. For the vertex B is adjacency list, you have to scan. So I think adjacency, listen, array also, linked list also, both you will scan. So answer is going to be V plus E. T1, answer is V plus E. T1 answer is going to be V plus E, everyone know that. Go to the T2. T2, I think universal sync, we are already done, order of V, already we done. Next one, T3. T3, I think it is the min heap or max heap, deleting an element. What is the answer? He is saying that depth is D. So depth means number of levels. I think answer is going to be, right, deleting an element in the min heap or max heap will take order of log n. Here log n plus D there. So what is the answer now? So answer is going to be B, order of log n, but not order of 1. You cannot say 1 is the answer. Best case may be 1, right? Every case you cannot say 1, right? Please be careful. Order of log n, but not 1. Deleting an element will take in the min heap or max heap, will, right? Deleting an element in the min heap or max heap will take worst case, average case, log n. Best case 1. Big O means what? Something like upper bound. So answer is going to be B, right? But not A, but not C, but not D, right? Please be careful. B. Next one, T3 is B. Go to the T4. T4. T4 is, I think, very simple one. I think you can verify once. Answer is 8. T5. T5. So BST is given to find out the sorted order, apply in order. BST given to find out the sorted order, apply in order, which will take order of n time. BST, sorted order if you want, just to do in order, which will take order of n time, which will give sorted order. One more, min heap or max heap, whatever it is. Min heap or max heap, right? If you want to get the sorted order, what is the answer? Delete 1 by 1, 1 by 1, 1 by 1. Sorted order if you want, delete 1 by 1, 1 by 1. What is the answer? Every deletion log n, like that n time, n log n. So BST is sorting required order of n, min heap tree or max heap tree sorting required n log n. Best one is going to be BST. Best one, BST. Time complex tree, order of n. BST in order is sorted order. Time complex tree, order of n. But if you go to the min heap, every deletion log n, like that n times n log n. That is the question number T5. Next one, question number T6. T6 is the normal only min heap, I think, right? Min heapify method or max heapify method, whatever is there. Just ask both the children accordingly. So this is the normal one only. Please check yourself. B is the answer. T7. T7 is a nice problem. Please verify properly. T7 is a nice problem. Please verify properly. T7 is saying that on the given graph, apply Prim's algorithm. Apply Kruskal algorithm also. Let us assume that this is one. On the given graph, Prim's algorithm I applied. On the given graph, Kruskal algorithm also I applied. Different approaches. Assume that when I applied the Prim's algorithm, assume that. See this one. These are the edges how came. Right? First Prim's algorithm, according to Prim's algorithm I followed, right? Assume that first edge 5 came. Next edge 3 came. next edge 7 came, next edge 1 came, assume some edge sequence. On the given graph, I applied Prim's algorithm, right? So E5, E3, E7, something like that came, E1 and E4 and E6, assume that something like that came. When I apply Kruskal algorithm, it is having its own story. When I apply Kruskal algorithm, right, assume the edges came like this. First E7 came, next E1 came, next E6 came, next E5 came, next E3 came, next E4 came. How many edges here? 6 people, here also 6 people, like that came. Prim's algorithm I applied in the given graph. This is the edge sequence I got. Kruskal algorithm also I applied. This is the edge sequence I got. Now can you help me one small line now? In the Prim's algorithm, edge 5 there in which place? First place. In the Kruskal algorithm, edge 5 there in which place? Fourth place. What is the difference? I think 3. In the similar way, in the Prim's algorithm, edge 3 there in which place? Second place. But where is the edge 3 in the Kruskal? I think 5th place. So what are the 2 minus 5? 3. What are the 1 minus 4? 3. That is also okay. Forget about it. I think he is given mod operator. That is okay. Can you help? Prim's algorithm, edge 7. There, third place. Where is the edge 7 here? First place. Check here. 3 minus 1. 2. In the similar way, edge 1 is there in the fourth place here. Here, second place. 4 minus 2. Which is going to be 2. Next one, edge 4 there in the 5th place here. Edge 4 there in the 6th place here. 5 minus 6 is going to be 1. Next one, edge 6 there in the 6th place. Edge 6 is here, third place. What is the difference? 3. Can you say what is the larger difference until now? Larger difference until now what? I think edge 6 if you see, right, edge 4 if you see, which place? 5. But here, 6th place. Difference is 1. I think if you observe clearly, no one having more than 3. E7, it is the 3, it is the 1. E1, it is the 4, it is the 2. 2 only. E6, right, it is the 6, it is the 3. Next one, E5, what is this one? 1, this is 4, 3. E3, this is going to be 5, that is going to be 2, I think 3. So maximum difference is 3, right? But the question here is, listen everyone now, he is asking on the given graph, if you apply Prim's algorithm, if you apply Kruskal algorithm, edge sequence find out, right? Same edge in the Prim's algorithm, which place came? Same edge in the Kruskal algorithm, which place came? See the difference. You want maximum difference, but what is the problem? Maximum difference you want, it is the right? You know very well. You will find out that is also okay, but the twist in this problem. But the twist in this problem is going to be, right? Kruskal algorithm having only one edge sequence, but Prim's algorithm having many edge sequences. So starting with A, right? One edge sequence you will get. Starting with B, one more edge sequence you will get. Starting with C, one more edge sequence you will get. How will you handle this? Kruskal algorithm having only one edge sequence because take minimum. But Prim's algorithm starting, depending upon starting vertex, right? Answer is keep on changing. If you start from A, one edge sequence you will get. Starting from B, one more edge sequence you will get. Right? Now some people are asking, sir, how to solve this one. Right? So if you start from A, one edge sequence you will get. Kruskal is already there. In that, best answer find out. Best difference find out. Starting B also you try. One sequence will come. This is same. Right? Find the maximum difference. That is also. Like that if you keep on doing, it will take a lot of time. If you keep on doing like this one, it will take a lot of time. Everyone know, right? So that is the twist in this problem. It is a very nice problem. Question number T7 saying that on the given graph, if you apply Prim's algorithm, right, some edge sequence came. Kruskal algorithm, some edge sequence came. Now, let's talk about some edge. Assume that edge E5. Edge E5 in the Prim's algorithm, which place? Edge E5 in the Kruskal algorithm, which place? Find out. Right? Difference you see. Like that, for every edges, find out the difference maximum. But what is the problem? Prim's algorithm having so many sequences. Which sequence you will consider? I will consider that sequence which will give maximum difference. Prim's algorithm having so many sequences, which sequence you will take so that maximum difference will come. I think problem is almost over. What is the answer? Kruskal algorithm, if you observe, first, see this one, first minimum, second minimum, third minimum, fourth minimum, and so on. Right? Listen everyone now. Kruskal algorithm, first minimum edge weight, second minimum edge weight, third minimum edge weight, fourth minimum edge weight, fifth minimum edge weight, sixth minimum edge weight. Assume that sixth minimum edge weight means it is the larger one. Sixth minimum edge is, assume that A to B is the sixth minimum edge. First minimum edge is some edge. Next minimum. Assume that in the Kruskal algorithm, last minimum edge, larger one is A to B edge weight. Assume. Now listen everyone. Kruskal algorithm, last minimum, which is the maximum edge weight is this one, which is there in the MST. Now what will you do is in the case of the Prim's algorithm, right? In the case of Prim's algorithm, you can start from A also, you can start from B also, you can start from C also, you can start from anywhere. But I will start with that one, which will give maximum difference. I think answer is over. What is the answer? Here A to B came last place, right? But I want to bring A to B first place here. So that A to B is there in the sixth place here. That A to B I will bring first place here. Some people are asking, in the Prim's algorithm, how will you bring A to B first place? What is the answer? Start Prim's algorithm from A. Most probably A adjacent people B will come. So instead of starting Prim's algorithm from anywhere, Kruskal algorithm with last person, start Prim's algorithm. So that Kruskal algorithm last person will come to Prim's algorithm first place. So that you will see the maximum difference. Assume that here, right, edge E4 is came here. Suppose edge E4 is came in the Prim's algorithm first place only. What is the answer? 6 minus 1. Maximum difference 5 will come. Can you help me now? What is the difficulty you are facing here? Prim's algorithm having many answers. Which answer I will take? Take that answer which will give maximum difference. How will you find out? Kruskal algorithm, whoever is the last edge, right? Last edge is assume that A to B. A is the vertex, B is the vertex. A to B, that edge whatever there, right? Kruskal algorithm last edge is A to B. Now Prim's algorithm, don't start wherever you want. Start with A, Prim's algorithm, so that A associated things will come first only. Assume that if you are lucky, A associated thing is B, it may come first place. So in the Kruskal algorithm, A be there in the last place. In the Prim's algorithm, A be there in the first place. Maximum difference will come. Suppose assume that, right? Kruskal algorithm last person, you tried in the Prim's algorithm first place. With the A you tried. When you tried with the A, you are expecting A to B will come. But A to B is not came. Something else came. Then what will you do? Maybe, suppose because of you are unlucky it is not came, A to B. Maybe next place it will come. Continue. Suppose next place came. What is the answer? A to B there in the Kruskal algorithm last place, sixth place. But here second place, 6 minus 2, 4. If at all here itself will come, right? 5. Here comes 4, like that. Suppose here also missing, then maybe 6 minus 3. What is the answer? 3. Some people are asking, suppose that if I do like this one, nowhere matching, then what is the answer? I think starting from A, right? Kruskal algorithm last person is A to B. With the A you tried Prim's algorithm. It is not working, then what will you do? B also try. Because A to B, I think edge contain 2 vertices. With the A you try, if you get the maximum, well and good. If you don't get maximum with the A, try with the B. B may bring better answer. So I think like that you can do. Suppose that A I tried, I got 5. B I tried, I got 6. Which is the better? 6. But one thing, right? Suppose that A I done, 3 I got. B I done, I got 1. Assume. Then you cannot decide A is giving 2, B is giving 1. Answer is going to be 2. Like that you cannot, right? I think by taking this one, in the Prim's algorithm first place you tried. Suppose that they are giving very less, assume, right? Then take the next maximum. With that you try, like that. Instead of trying Prim's algorithm blindly from any vertex, Kruskal algorithm last person, try Prim's algorithm. So Kruskal algorithm, whoever came in the last place, with those people you try Prim's algorithm, you may get the within less time maximum answers you will get. This is a nice problem. Please be careful. I done this one. Listen everyone, in the C2Q I done. This problem I done in the C2Q. Right? Please verify once. Because if I already done, I don't want to do it again. Right? Please try yourself. To this problem. Can you help me now? What is the logic for the question number T7? Question number T7, what is the logic? Kruskal algorithm do normal. But in the Kruskal algorithm, whichever edge came last, with that person do Prim's algorithm. So that you will see the maximum difference. Because Kruskal last person, Prim's algorithm first place came, maximum difference will come. Suppose with this last person you tried, still not came, right? Try further, maybe second place he will come. Then at least then also little bit maximum. Still not came, next person, still not came, next person, like that continue. Suppose by taking this person if I try, best answer is not coming, try before this. Next maximum you try. Next maximum you try. Like that if you do 2 or 3 times you will get. If you don't do that, blindly if you take any vertex and if you give, you will get any answer. You want any answer or maximum answer? If you want maximum answer, try with maximum vertex. How to get with maximum vertex? Kruskal last person. Try with the Prim's algorithm so that you will get first place. Right? This is the logic. I'm thinking that question number T7, little bit you got, it is there in the C2Q also, please verify. Answer is going to be, you will get the best answer 6. Maximum you will get 6. Right? Fine. Go to the next one now. T7 over T8. T8. Complexity of Kruskal algorithm for finding the minimum cost spanning tree of an undirected graph contain n vertices, m edges if the edges are already sorted. If edge weights are already sorted, Kruskal algorithm saying take minimum. Then what is the answer? Because of you are taking all the edges. Worst case what will happen? All edges you have to take. M edges are the order of m time. Take first minimum edge weight constant. Take next minimum edge weight constant. Take next minimum edge weight constant. Like that continue. Right? Like that all edges are over. Sometimes only I want. Right? I want only n minus 1 edges. Because of cycle and all, right? I have to take worst case all edges, order of m. And one more, cycle checking. Cycle checking will take constant time in every step. First minimum, constant time cycle checking. Second minimum, constant time cycle checking, and so on. Using disjoint set data structure. Find and union operation. If you implement them using, right? Disjoint set data structure, operations are find and union. If you implement using, right? Union by rank and path compression, it will take constant time. That is the reason cycle checking will take constant time, so total time complexity becomes order of n. Next one, that is the T8, answer is order of n. Go to the next one, T9. T9. There is a graph, for the graph, there is a graph G. To that graph, they constructed one MST, that is T. For the graph G, they constructed MST, that is the T. Next what happened is this one. Next what happened is, so that is the thing what he mentioned. Next one, see the next line. Suppose that we decreased the weight of one of the edge present in G but not in T. Right? See this one. It is the MST. Assume that A, B, C, D. It is the MST, assume. A, B, C, D. This is the MST, A, B, C, D. This is the MST already. For this graph, already MST created, it's okay. Now see the next one. Now next see this one. For the given graph, he constructed MST and everything is fine. Now see the answer. In this graph, right, maybe 3 edges I written, many edges are there. This is also one of the edge. In this graph, right, these are the 3 edges which are part of the MST, that's okay, right. Many edges are there. See this one. It is also one edge, it is also one edge. Many edges are there. Right? Let's talk about some edge. This is the edge. Listen, this is the edge. This edge weight is 30, assume. In the given graph, there is one edge, weight 30. So, on this graph, where this edge weight is 30 and some more edges are there, on this graph, I applied the minimum cost spanning tree concept. I got MST like this. What is the meaning? This edge is not came in the MST. I am repeating once again. There is a graph. To that graph, I constructed MST, that's okay. But in the original graph, there is edge from A to C, which is the 30, right? That edge is there in the graph, but that edge is not there in the MST, because he may be larger, that is the reason he is not came. Now see what happened. Suppose that we decreased the weight of one of the edge present in G, but not in T. What is the meaning? In the given graph, there is a one edge, weight is 30, right? But it is there in the graph, but it is not there in the MST. What is the reason? He may be more, that is the reason he is not came. Now see what happened. On the given graph, after constructing MST, right, this edge is there in the graph, but not there in the spanning tree, that is everything fine. Then what happened is, he took the given graph again, He took the given graph again and he went to the edge, right, 30, which is there in the graph, which is not there in the MST. He went there, he decreased this edge weight 30 by 3. He decreased it. Suppose that we decrease the weight of one of the edge present in G but not in T. After MST construction is over, he went to the original graph, one of the edge which is there in the graph, which is not there in the MST, he decreased the edge weight. But when you decrease the edge weight, I think graph is changed. He may be very small, he may go in the MST also. Now, for the modified graph to create MST, how much time it will take? For the modified graph to create MST, how much time it will take? Without modification, MST I have already. After modification, right, if you create MST, for the modified graph to create MST, how much time it will take? Because of only one edge weight is changed, that is also decremented. Right? So, only for one small modification, why should I create the total MST process again? What is the best idea? Which edge weight you decreased? Take that edge. Who is that? A to C. Just go to MST, right? In that MST, A to C you add. How much? 3. By adding A to C, cycle will come. By adding A to C, cycle will come because it is already MST. If you add one more, cycle will come, nothing there. Whenever cycle will come, what will you do is, right? In that cycle, larger one find out. In that cycle, right, by adding this one cycle came, in that cycle, larger one find out. Supposing that this only larger, he will come out. If not larger, someone else will come out, right, nothing there. Because of only one small change, right, that small edge, right, take that edge and keep in the MST. By adding that one, because of the MST, you added one more, cycle will come. In that cycle, whoever is larger, delete it. Can you help me now? How many edges are there in the given graph? I think V vertices are there, actually V minus 1 edges. By adding one more, now V vertices and V edges. In those V edges, right, cycle came, in those V edges, what will you do? Whichever is the larger edge, delete it. I think out of V people finding the maximum person, because you have to delete, out of V people finding maximum will take V time. So, for the modified graph to create MST, simply finding maximum and deleting that. If this only maximum, delete him. If someone else maximum, delete him. You have to find maximum, nothing there. After adding the modified edge weight in the MST, cycle guarantee will come. No need to check cycle is there also or not. No need to check also. Cycle guarantee will come, right? What will you do is, in that cycle, whoever is larger, delete. How to find out larger? Out of the available cycle, whoever is larger, delete it. Find larger edge in cycle and delete. Find larger edge in cycle, not in the overall. Find larger edge in cycle and delete. Right? Finding larger will take. Right? Worst case, what is the answer? V people are there. V time. So, answer is going to be order of V. It is a nice problem, please take care. Roughly I explained. T9, answer is V, you know. If anyone don't know how, I explained little bit. So, what is the problem here? Already for the given graph MST there. Now, what he done is, after some time, he went to the graph. In the graph, one of the edge there, which is not there in the MST, he decreased that edge weight. Because of you decreased one of the edge weight, right, this edge may be most probable will go inside MST. So, for modified graph, how to construct MST? No need to do entire procedure again. What is the best idea? Modified edge take, go inside MST, add it. Cycle came. In that cycle, larger one delete. How to find out larger? Finding maximum element in the given array. V people finding maximum V time. After finding, delete it. So, which will take V time. Because out of N people finding maximum N time, out of V people finding maximum V time. Some people are asking, sir, number of edges are E. How can you write V? But in the MST, V vertices, V minus 1 edges. Because of one more edge added, total edges becomes V. Out of V people finding maximum will take V time. So, for the T9, right, answer is going to be order of V. I explained little bit. I didn't explain that much clearly. Roughly I explained order of V time.